Jacques?
Yes, ma'am.
For question C, how are you calculating your variance of the phenotype? Wouldn't you just do the
VP.
bar S of the trait from the provided data set?
Yep. It's I did what Kyle showed last night, which is I created a pivot table. Here, let me expand here and show you. And I was even on that page. So I created a pivot table, so I got the average of T1, and then I did the var S of it, and then I changed it out and did the average of T2, and did the var S of it.
Okay, that's why I was getting different numbers, because I was just taking...
Yeah, that's what I had said too, but he said you need the entry means. So.
Let me see. Yeah, of course, that makes sense.
Yep. And then that plugs in with the rest of it.
Mm-hmm. Perfect.
Everybody else getting these general, everybody else should be getting these same values, right?
I'm just calculating VP right now. I need to get my VP so that I can calculate VG, so.
Yeah, but what about Chelsea and Emily?
Yeah, I feel like mine were slightly different. We'll compare.
The question is, did you calculate your VP the same way?
Thought so.
Okay.
Because how did you do yours?
Created a pivot table.
Yep.
Did
just the VARS?
Well, did the average of all the RILs, and then the var S of all those averages.
Yeah, so my VP looks the same. My VG 134. Oh, it's just the difference in my rounding.
Okay.
Yep, that's the same.
That rounding.
Did you get the same mean squares and in real environment mean squares? Those are from my ANOVAs.
Yeah.
Okay.
Looks
I'm thinking they should be pretty close to the same, although I ran a full ANOVA with all the possible interactions.
Sure. Yeah, no, it looks the same. It was just, I didn't recognize the .004. I was like, I'm pretty sure mine was higher than that. But yeah, it's just rounding when I opened it.
Yeah, these are really low heritabilities too. I suppose we can expect that because these are F5s, right?
Yeah.
Yeah, okay.
Wow!
Has anybody taken a stab at D?
Not yet. Not any further.
Because I think we generated last night, didn't we? Generate the estimated GEBV, but how to plot it. Yeah, because we were looking for that average phenotypic value kind of threw us, I think.
And the gaps.
Mm-hmm.
Okay, now I am getting the same. Now that I'm doing it the entry mean way for BP. I guess
Now going back to 1B and 1C, did you figure out the formula for that? I haven't looked at that yet.
I'm still getting something different, and so that page 67 in the book, using that same equation, I calculate it right for their examples, but I'm getting something different than Chelsea and.
What's the formula? I don't have it handy. That you're using out of the book.
It's p squared times it'd be the AABB number observed plus 2pq times the AAB little b value plus q squared, and then the AA little b value.
Okay, so it's involved, and that's that's to calculate the A.
That's the mean of A, yeah.
For A, and then there's
so that'd be doing weighted instead of unweighted.
Okay. What I'm getting at is we're not looking for GAA and G dominant AA, G heterozygote AA. It's just going to be GA, right?
No, you'd still do all three, I think.
All three of them weighted? Okay.
Yeah.
All right, let's go.
Hi, everyone.
Hello, Dr. Beavis.
Something that I want to mention to you in the part A, and I'm almost ready to get it back to you. I've still got one to grade that's a little bit difficult. But anyway, for marker predicted genotypic values, I don't know what I called it in this exam, or part B exam. You guys were just working on it. Let me see if I can pull it up, because, okay. Genomic estimate breeding values, part D. In part for question 2D, and there was something like this. It was like question 8, do the predicted values. A lot of people didn't do predicted values. What they did were simulated values, and so these estimated breeding values, you need to use RR-BLUP to do that.
Okay. That's what we did for this.
Okay. Yeah.
Just a sec.
Because, I was using the same code I used last week. It was the only thing.
I'm just getting R warmed up, all the old vacuum tubes have to.
Yeah. So I just wanted to make sure it was clear, because for a number of people, they ended up putting in the values that the phenotypic values, but they were phenotypic values that were the simulated values as opposed to what should have been predicted values. So
So are we supposed to use the genotypic values and the phenotypic values predicted by R? Or like that we get with the RR block?
That's right. Yeah, these genetic estimated breeding values, they come out of our blood, not out of any of the simulation stuff. In part 3A, there were a number of people that just took the simulated values and took some kind of average of them and compared that with the LS means.
Okay.
Yeah. And so I just wanted to make sure.
Okay, but the GVs would be the predicted genotypic values that we got from RR blood, and then divided by the LS means to get that.
No, you wouldn't divide it by.
Or sorry, I was thinking of the correlation. Do a correlation.
Right, that's what the correlation would be based on. Yeah.
Right.
Okay, and then, so in exam B, question 2D, that's what you're asking us to do again, right? Because it said the average phenotypic values, and I wasn't sure if that meant the predicted phenotypic values.
Yeah, so combine, use the combined genotypic and phenotypic means. Okay, so the phenotypic means are LS means. And then there's the genotypic values, it probably should say, and phenotypic means to develop a model that will come up with these genomic estimated breeding values. Yeah, so it shouldn't read combined genotypic means. It should read combined genotypic values and phenotypic means.
But that phenotypic mean is what we should get for like the predicted from R, or is it from like the original data? Because like the original data set, we only had half of the phenotypic values.
Oh, yeah, no, yeah, that's all you can, yeah.
Yeah, so
That's all you
once
can use, yeah, that's all you can use. Because you don't have phenotypic values from, well, it turns out they do exist, but only in the simulated sense. They don't really exist in what actually went into the field. What actually went into the field was less than half of the data,
Okay.
or half of the rows.
Sorry, which question on exam part A were you talking about? Was it just that
It was question 8.
question 8? Okay, thank you.
Yeah. So I was getting getting values back that looked just like the simulated values, as opposed to the RR bluff generated values. From a fair number of people. I'm not saying any of you did it. I'm just saying. I just want to make sure it's clear.
Okay, yeah. So I'll share my screen just to make sure I understand right. But so these were the values that I had got out of R. So I mean, they're different than the original, but this is what we should be getting, correct? Like a GV value directly out of R and a predicted phenotype.
That's right. Yeah.
Okay, excellent.
Well,
Thank you.
Yeah. Yes. The trait did. So yeah,
That came out of, so I don't have my original data in here, but like my original was 209.5 for that, and my new one is 212.17.
Right, yeah, and value, did you get that out of R also?
Yes.
Okay, so one of them was just had the mean added back onto it.
Okay.
Yeah.
But these two things would be what I'd be comparing then,
So
or
you'll be comparing that with the LS means.
okay,
Now,
so we
I mean,
only are able to do that for the half of the data we have.
That's right. Yeah.
Okay.
Yeah.
All right.
Why can't I do that? Yeah, part D, I guess, you're just going to be able to do it for that half of the data set that you have.
Okay.
Yeah.
That was what we were debating last night, if we compared like that GV we got with the predicted phenotype, just because we'd have data for everything. But yeah, or if it was the LS means versus the predicted, since for half the data. But okay, thank you.
Yep, that's it.
Doesn't if you just compare the predicted and genotype and the genotypic value and the predicted phenotype, that comes out to the correlation of 1 always, doesn't it?
Yeah, I think that's right. I think we saw that last week, yeah. And we avoided doing that, I thought.
Yeah, okay. Yeah, like I say, some of you, this was a non-issue, but for others it was something that, and I just want to make sure I well, you'll get the, I'll be sending out the grades from Part A pretty soon, and when that happens, you'll see it. Some of you will see it, others, everything's fine, so. And hopefully, I just wanted to make sure that everybody was aware that the GEDVs are not the things that you simulate, they're the things that you estimate. All right, good. I guess you've picked up the correct question number 1.
Yes.
Yeah. So, yeah, average number of cysts, those would be weighted in the original data set that I sent out, but it just wasn't clear. So that's why I changed the table, so that these are now averages that are unweighted averages.
Unweighted averages.
Yeah, I think it says it in the table now.
Yeah, it does.
It's unweighted number of cysts, average, yeah, something like that. Unweighted average number of cysts.
I just grabbed the numbers because the way that it was formatted made the questions keep moving around with the data set when you tried to type, so I just deleted that table and just grabbed the numbers.
Okay.
It's funny formatting.
Oh, is that right? Yeah.
Yeah, it was weird. I didn't know how to like unlock the table from the text, and it kept just like shuffling down the text
Oh,
document.
geez. Yeah, okay. Yeah, what a mess.
I think most of us just like retyped it in Excel and then worked out of that because you need to plug out of it anyway.
Yeah, that's right.
So.
Yeah, that's right. To answer it, you got to. At least I would have to use Excel. I suppose I could do it by hand, but I wouldn't like that.
Well, and it was good that we did like plug everything into Excel and then have it all feed through each other, because then when you change or put the changes in, it was pretty easy to just like change them and then it just fixed itself.
Yeah. Okay.
Except for maybe the point of contention where there's some unmatched answers that we have to figure out, but
Oh. Okay. Yeah. You guys will have to resolve that.
yeah, different scores for dominance and different scores for the
Oh.
averages. We're getting different things, so we have to figure out why.
Yeah. All right. If you listened to the discussion yesterday, you realize that there won't be a discussion tomorrow. That'll be posted. But if you have any questions at all, just contact me by email. Or I'll look at the discussion board occasionally, see if there's anything that's still not resolved.
Sounds good. Hopefully we'll have it all done before we go to bed tomorrow.
Yeah, that'd be great. You're allowed to turn it in early if you want. Okay, I'll let you go. Oh, there is something. Apparently, you all need to assess the class. There's some kind of thing within Canvas where you're supposed to fill out some kind of survey. I would appreciate it if you would do that, because otherwise the class, the people who run Canvas send me nasty notes telling me that only a third of the class has responded. So, yeah, it would help me avoid those kind of nasty grams that they send me. They're just automatically generated, so.
No, they're making sure we won't forget. I think I've gotten 1 or 2 emails a day being like, "Hey."
Yeah, they send you things too.
Yeah, we get them too. So everyone should have this at top of mind.
Okay.
It'll get done before the end of the weekend.
All right. Well, thanks everyone.
Yeah, thank you.
Thank you.
You bet. Bye-bye.
So Chelsea, would you be willing to go over, just the A locus, the first one, just to see where I'm going wrong? Because you are using that equation, right? So p squared times the number, in each. So for A locus, for each value of those, pretty much, right? So p squared for big A, big B, like that number, plus 2pq, the next one, and then q squared and the third one in the table, right?
Yeah, so it's like for the big A one, I would do like the 51 times the 0.09 plus the 124 times the 0.42 plus the 274 times the 0.49.
Okay. I thought I got like 77 or something when I did that.
I took a double look at mine, and I don't. That's exactly what I'm doing, so I don't know why it would be coming out differently.
Oh, check that. Okay, I get it now. I actually had a squared in one of my equations, and that's what was messing it up.
Oh, okay. Yeah, that's like, I don't know, at the very bottom of that one set of notes, I know he has that chart, and it's like way at the bottom, like past any of the writing, and there's like no, like I couldn't find anything around it that explained how they got those numbers.
It's just
Well, yeah, that's why, I made a calculation and figured out, the exact same value, and then I had done it, except then I was getting, 207. It's like, okay, well, that's not right. But, yeah, the text explains it better.
Yeah, that's why. So then, because I couldn't find anything in the notes that explained how he got that chart, and so I went to the textbook, and then, yeah, I find Bernardo is actually really good at explaining a lot of it.
Yeah, because, in the notes, I calculated it out as if you multiplied each of the values within, the box. So I think AA BB was 24 times 0.0256 and added all 3 of them together and then divided it by the total frequency. So, the 0.64, I got the exact same value.
Wow.
So that's how I had done, it originally. I got the 207 when I was trying, and it's like, okay, that's not at all what they're getting. What's going on? So, thank you.
Yeah, no problem.
Okay, so what did I miss? My internet just completely cut out. I literally heard Chelsea say, "Oh, I took this times," and then it cut out.
That's funny.
So pretty much just take your A value, so like 51 times your BB frequency for each of them, and add that together. I had a squared in one of my equations, and that's what was messing it up.
51 times
Times
your
point,
BB.
yeah, 0.09, right?
Yeah.
And that becomes
4.59.
well, yeah, but you have to add for all three of them for the whole column to get your G, capital A, right?
Mm-hmm.
Okay, so I would do that for big B, little b, and then little b. And do you add those together?
Yeah.
Yeah, okay.
Yep.
That makes sense. And it's weighted, and we're not making up random equations trying to figure
So
out.
did you get 190.93, Michelle?
Yeah.
Okay.
And that's what Chelsea and Jonathan had posted.
Works for me.
I got 403.5 for AA. Well, I think I'm doing it wrong. So it'd be bracket 51 times 0.09, bracket close, plus 124. Oh, I didn't multiply those, I added them. I bet you that changes things. I got 190.93.
Yeah.
Yeah, look at me go.
And what are you talking about with the geometric values? The way we had all talked about doing it should have been the correct way then, right? Oh, and you're
I'm
talking
assuming so.
okay.
Yeah.
I'm
At least
making,
that's how I think I
yeah.
did it. Like,
Yeah, I'm like, so I think you're saying that we're supposed to do it the way that we did it?
yeah, because I remember, like, once you said the correlation, that was exactly what we found last week, and we didn't do that.
Right.
Yeah.
Like, I'm positive we didn't.
Right, that's what I was trying to figure out if that's what he was referring to, because I'm like, if that was the question that he was talking about. But then I didn't know if he was trying to say that we were supposed to use the predicted phenotypic value. But I thought that doesn't make sense, because it will like always be 1 if you do the correlation between the predicted genotypic value and predicted phenotypic value.
Yeah, that's exactly right. It just confuses me, like, the way he had the question worded.
Yeah, I haven't actually even looked at question 2 for this part, so.
We'll get there. I plan on having a very riveting Friday night online, so I feel like one of those
No, I mean, I feel like we don't have that much left.
No, like I think if
Okay.
we crush it out on Friday, that we could be free.
I'm a little
Alright,
scared
Kate,
of
post this again. Is this what values you guys have? I'm not posting it a third time to be wrong.
I only did my bottoms, but those match them. I have to do my tops still.
How did you get the minus 4.25 for your epistatic values?
Oh, yeah. That's different.
Yeah, mine are 0.
What the heck? They were 0.
Yeah, that's what I thought. I'm like, I thought when you posted earlier they were 0, because I agreed with, I had all the same answers as you, except for that,
Mine epistatics came to life too and turned into a different number, but it's probably just been working on
Because,
something.
oh,
because,
you did it, you changed your GAA value. So
yep,
you still need to use the unweighted average.
for the epistatic and
I think.
non-epistatic. Yeah, yeah.
What did you do for your allelic effects? Because I had used the same equation. I have the updated chart and everything, but my numbers are different.
That's not right.
Just a second.
It is this plus this mine and added together, then minus that, right? To get the unweighted. Because these are the unweighted right here.
I think the unweighted is just what you had before.
Well,
It's just the 51 plus 124 plus 274 divided by 3.
The average of them?
Yeah.
okay, yeah, so 150, right, I got that, but isn't it 150 and 137? To put it in here? See what I'm saying? Because we're doing that, the non-epistatic for BBAA, both capital, so it's got to be these two, doesn't it? And then that should, no, I have to double check and see, that should be, yeah, that's right. But that's giving me a 52. And then a -1 down here.
Yeah, but isn't that number that you're using, that 235, using... Is that...
That's just the average of everything in the middle, right?
Yeah.
So what are you doing the others for?
These are the non-weighted averages. Or am I not understanding your question correctly, Michelle?
I mean, yeah, I don't know why I still had mine set up the old way, but that should be the same thing because decimals, so slightly different, but it should be basically 136 plus 150 minus 235. And what's the value you're getting? Lose them?
I'm
I think
back.
so.
Okay.
My internet's cutting in and out. It's going to be that kind of night. I knew the last night it's going to be like that. Anyways, I'll go back to this. So, and
Yeah, well, and I've got the same thing as Jacques too, where all of my epistatic turned into negative 4.25 after I made my changes.
Okay, so you changed it and just connected it to the original columns in the file, and that's the difference from losing just that little bit of decimals?
Yeah, like it should be 51 minus 55.25, because that's my non-epistatic value now, and then that non-epistatic value was calculated from, 190.93.
okay,
Plus
I'll see how long they last.
Whatever that equals, minus the overall, which would be 235. Like, if I throw some brackets on there.
Are you guys getting different answers?
No, I've got the same thing you have, where my epistatic is negative 4.25 for everything now.
Okay. How about you, Michelle?
I hadn't changed mine yet, but when if I just plug in and change, because all you're doing is changing your values from previously going off the mean we calculated to the value.
Mm-hmm.
So for the first one, that only changes mine from 51 to 52, and then I have an epistatic value of 1.
Okay. Mine's
But
-1, but because we're supposed to use the unweighted means, I thought.
or yeah, I guess it would be -1. But didn't you have 4?
Yeah,
Or
that's when I
something?
had. That's when I use it off of the weighted means instead of the unweighted means.
Yeah, I'm confused.
So what do we need to use it off of?
Yeah, that's
I
what
thought.
I thought we were supposed to use it off of the unweighted means.
Yeah, I thought so too.
For the epistatic?
The non-epistatic, yeah, because that's the way the notes show it.
Yeah, so I
But then
have
what we
mine
had-
off of the weighted right now,
Okay.
so I could change it.
So yeah, I'm just gonna leave mine as is because calculating it was more precise with the decimals than just using, I mean, we could round to his values, and I get like -1. But I think I'm just going to use what I...
Well, -1 is better, right? Or, I'm sorry, geez, correct. -1 should be the value, shouldn't it? Geez, for a second there I thought I lost you guys again.
No. Yeah, so I'm just confused now. I don't know if I have these plugged properly.
I'm going to use the unweighted means, and I don't care.
Just use the ones he gave us instead of just calculating it out. So then that changes it to -1 instead of 0.
If you do the 51 plus 124 plus 274 to get the divided by 3 to get the unweighted values, like that's how I saw them doing it in the notes, was then using that GAA to do everything.
Yeah.
And then instead of 190 for AA, it would be like 149.
I'm assuming that his are what he has is just the rounded numbers.
Yeah, that's all it is. So, I mean, if we plugged in just what he gave us instead of our calculation, that change in decimal makes it -1 instead of 0. But do we really need to do that?
Yeah, I'm going to share my screen for a second just to make sure that I'm understanding. So, like, this is what we had before, and this is what we changed it to.
But I mean, 149.6667 is just the same as what he has, just 150 is the rounded number.
Mm-hmm.
Yeah, so, I mean, it's more accurate, I'd say. So, that's why I was going to leave mine, and then it's 0. But if you went off of his 150, then it changes everything to -1 if you go off the rounded.
So now, instead of having this as 190, I would change this to this. And then this would change to this. So now, I see. And that's going to change these, because they're going to see off of. Okay.
Yeah,
And then-
so you could keep the ones we calculated, the unweighted, and still get 0s for everything. Or you can use the ones that he gave, and just you lose the decimal places, so then you get, like, if you use both of his, it's
Yeah, so it's just like whether you want nice numbers or not.
yeah, pretty much.
Okay. And then the other thing that was not matching was the dominance variances. We were not getting the same thing as Chelsea.
No, I had the same thing as you guys, which is why I asked John what
Oh, it was John. I thought you and John had
I said
different
that I had the
stuff, and
same
was
thing
like,
as John for the locus, and then I asked him what formula he'd been using to get the additive variance or the dominance variance.
I get
I was not matching him with. I was matching Chop.
you. Okay.
Yeah, because he must just be using a different formula. Is the only answer if everything else matches up.
Mm-hmm.
I can confirm, in case I haven't heard anybody talking about it, that if you if you do not use his rounding, you get the 0s. I know you probably already said that, but I'm just setting the formula up for that, and lo and behold.
Yeah. I'm just going to leave it with what we did yesterday for those.
Values that appeals to
Yeah.
my sensibilities.
And I can be like, it doesn't exist. There's no epistasis.
I like that. That makes me feel happy inside.
No one wants epistasis, really.
All right.
Okay, this isn't as nasty as I thought it would be. Usually when there's stuff that changes, it's kind of a nightmare, but this is okay.
All right.
Did anybody else having issues where R just ignores it when you're trying to do the ANOVA and include family?
It has to do with the order, I think. Because, like, everything else is coming back in your ANOVA, just that one isn't.
Well, anything that includes family. Like, I did family by environment, and neither of them show up. I've never had that before.
I've had in the past where my family didn't show up, and if I changed it to like the first variable in the equation, then it would show up.
Mhm.
But I don't know. I haven't done anything on question 2 yet, so I don't know about this set.
Okay, so I should go and check. I posted online the formula I was using for I. Have you had a chance to look at that, Michelle? Or Chelsea? Just to see if that matches? Because we were finding...
I knew which one you were using. I was curious which one John was using, because I was getting the same answer as you, and that's why I was wondering what John...
Oh, okay.
Sorry.
I have some questions about C. 2C.
Don't we all? Well, I'm not done with 2C at all.
I was calculating the VG and the heritability, and I was trying to follow what we did last week, but it wasn't making sense. Because for the VG, you need to have, it's like line minus G by E.
Yeah, and the G by E is your RIL by environment.
Oh, it's the RIL by environment. And then divide by 4.
Yep. 2 replications, 2 environments.
So when I do that, I get negative 46.
But what are your, here. I will.
So for your real mean square, what value do you have?
Yeah,
Real
this
mean
is,
square, I have 970. So
Yep.
were you guys going real mean square minus environment mean square?
minus RIL by environment mean square.
Yeah, so what did you have for that one? Real by environment.
433.
Okay, that's what I have.
Yeah, 970
I'm
minus
just-
4.
I'm plugging it wrong because I was doing it off of the phenotypic variance. So it's real environment minus real.
No, it's
No, that's the
RIL
other.
minus, right,
So
RIL.
970 minus the 433
And then divide that
divided
by
by
4.
4.
So it's 134.25.
That is correct, ma'am.
Oh, thank goodness, Kate. And then now I'm getting the same values as you guys.
Excellent.
It is excellent.
So that's C part 1. So, Michelle, you seem to understand what he was saying for part D.
Yeah.
So, could you explain that to me? Because I did not follow that.
So, I mean, I think we did it right. We have, like, the predicted phenotype, and then he just wants us to compare that to the LS mean, or the LS means we got for the phenotypes.
What's
So it's
the
only
predicted
gonna be-
phenotype?
We got that, we simulated that.
Is that our GEBV? No. I'm looking for what I've got for information here.
Let me pull
I've got my LS means.
Yeah, so when we got the 2 reports out of, like, you got 2 reports out of R, right?
Yep. Yeah.
So the one
Trait
is
1
the
and trait
predicted.
2.
Yep. So for trait 1 of them came back with like 212 in the first row, and then the other was the GV that was negative 8.5 is what I have. I can share my screen.
I don't know if I have that second one. Maybe that's why I'm having problems.
Oh, still not one. So I had got 2 out. So I got one that was this and one that was this.
Why do I not have the second one? I have the predicted phenotype. Well, wait a minute.
You only have this one? Well, either way, this one
Okay.
is the one we should compare to the LS means.
My numbers do not match up to yours.
Oh.
But I've got them by RIL. Oh, that's interesting. Why is that? I have my LS means, and I think we all matched up with LS means when we were checking it out.
Mm-hmm.
But my
So here are my LS means. Like the first one's 209.5. Is that what you have for trait 1?
just a sec here.
Sorry, I saw them in different tabs.
Yeah, 209.5 and 102. Okay, you have a 110.1. What's that?
This is
Is
the
that-
original. This is the original data. And
Yeah,
these
that's what
LS
I've got. I've got your G and your H match up with what I got as my out of.
Oh, this matches up with what came out R?
Yeah.
That's the original data.
Did I screw up? Hold on for a sec. Because I've got my. Okay, if I can find it. What the heck? T1 predicted GV that came right out of. Oh, I'm sorry, Michelle. Well, I've got my predicted. The only thing I have is the minus 8.5 for one, and
Okay.
for two, it is 1.23 E minus 0.7.
Mhm.
So those are the two that I got. But
Okay.
I don't have the trait 1 predicted phenotype.
So I think that was the very last part of the code you have to do. Like to write out the original data along with the predicted phenotype. Let me switch. So,
I like where John's numbers came from.
oh, okay, just a second. So this was the code, Jacques. So this little bottom part from his original code is what generates that.
I don't think I've seen that code. Or at least I don't have any of that in I'm looking through all of my code.
Yeah, because this all just came from whatever he provided for, I think, ALA 17? 16 or 17? 17.
Okay, here's 17.
Did you guys do subsets for 2A? And run each of them?
Yeah, I did a lot of subsets. I didn't run as many as last week. But yes.
Yeah, for environment family combinations.
Oh, I think I found what you were talking about now. I didn't run anything after the first part.
Okay.
Okay,
So yeah, then that should get you what you need.
Just,
And then
yeah, Y data. Do.
so yeah, that should get you what you need
So
then.
there's a
And then
second part, okay.
yeah, and then you just compare that predicted phenotype to the LS means. So we only have that for the original data in the phenotype file. So it's half the data. At least that's what he said tonight. So
Well, yeah, there's even code in here. Compare the GV with the predicted GV. Because that's, I think, what's throwing me is I've got the file format that we used to, when we created the FM,
mhm.
and then we use that for the pred GV. But there's also, I'm thinking this is what he wants us to do because there's a plotting of it
Yeah.
where you plot the pred GV by the GVAC.
Yeah, so it's not too bad.
I feel really dumb.
No worries. That's why, like, last night I was like, I don't know what's the huge problem. So
The
then
problem is
we needed
because-
the GV.
Yeah, we gutted this all out because he didn't want us doing that in 17.
Yeah.
And so it all just went bye-bye.
Okay. So yeah, we pretty
That
much just use exactly that code and get what we need, right? Because we do get that regression line or that plot.
That's what it looks like.
Excellent. All right. So Chelsea, you said you solved that. What did you figure out?
Oh, it just seems like John only squared the D value rather than the whole equation.
Oh, okay.
And
Yep.
if I did that, then I got the exact same numbers as he was giving. But it definitely shows in the notes that it's the 2PQD is all squared.
That's what I thought.
Good catch.
We were wrestling with that stuff last night, so it's not like anybody's an idiot. We had some fun running around dealing with what exactly got put in parentheses.
Yeah. So to get those, if we're looking at D, again now, question 3D. So you took the exam 3 part B genotype and then converted the ones and zeros and then run that to get the DBEV?
Yes.
Okay.
So,
I'm
and the thing to watch is that, well, so the second part where you do like I think it's the YVEC, you associate it to like your phenotype. Either I think I put it in Ellis means. You have to bring that in, but not all of your families that you have genotypic data for have that phenotypic data.
Yeah, because it's
So-
a data set.
Yes, so make sure you have, I think I left those as blanks. Didn't have like NA values there either. And I didn't put zeros in.
So you shared one last night, and I formatted mine similar to yours before I gave up and went to bed.
Oh, okay, yeah.
So,
The one
If
that worked for
there's-
Kyle?
yeah, if there's no T1, there's no T2.
Yeah.
Just gaps, so that we're not trying to run half of a data.
Yeah.
Okay, so Michelle, when you did your GVAC and you have to put in your number, were you comparing 15 and 16? So you've got your ZMAT 3 to 14, your YVEC is 15 for trait 1.
Mhm.
Did you do your GVAC, so, to get that, did you do that for 16, or do we have to put another line of code in there? Because it needs it's calling out a column.
The GVAC?
Yeah, compare the GV with the predicted GV, or did you not do that? Because that's how you can plot it. What was that?
Turn.
Are you using the original code he gave that
Yes.
had more information versus
Yeah.
the one that he cut out information?
Yes, because with the original information, I was wondering what you used to plot.
So I didn't directly compare 15 and 16. I was just comparing within the one. So my code's exactly what he provided after he gave us the update, not the original set of our code.
Okay, but isn't that missing all of the plotting?
No. I still have it in mine anyway.
All right, I'm gonna go check.
Let
out
me see if I can-
17 and
Data.
wrong one. I'm gonna pull down his code.
Hot toddies.
Let's see.
Oh, that's the one that
Oh, it wouldn't let me
Is-
plot.
'Cause, yeah, it looks like it's just comparing off of the genotypic values that's associated to the ZMAT and then the FMU, which was off of the
All right, I'm gonna go with
YVEC versus the ZMAT.
the simplest answer. Could you please share your code?
Sure.
And I will compare to what I have, because I pulled in everything that I pulled off of my notes, which was from watching the lecture.
Okay.
And so everything's in there, and we were able to plot this out, the predicted genotypic value with the predicted phenotypic value.
Mm-hmm. Yeah, I just pulled the R code that he posted online
Okay.
and went off that. But I think there was more in there originally, and then there were we kept running into some error
Mhm.
on part of it. Did that do everything?
Okay, predicted GV1 for E3.
Yeah, see, I can do that part without any problem, or I did already. I predicted GV1 and GV2. I just don't have the phenotypic.
Did it actually paste everything? I feel like my bottom line isn't showing up. Let me see where it cut off.
Probably isn't. If you shared, that's fine. I got 99% of this. It's just I want to compare exactly to what you've got in yours.
Yeah, so there's the predicted phenotypic. And then the predicted phenotypic is just like what we were given? Or is that the actual?
Okay, I think this is the rest of my code that it wasn't looking like it was showing on my screen.
Do you guys do all the ANOVAs again for the like family within each environment and stuff?
I did.
Yeah, I didn't do. I guess I ended up running them anyway, but I wasn't going to include just the individual family because he's really only asking for the family by environment combinations.
Yeah, that's what
I
I
just-
just do with the combos.
Yeah. Emily, what was your question? Sorry, I was distracted. Were you
I'm
asking
a
about
distraction.
where you got information?
Copy. Get out of here.
Did you get yours working?
Me?
Yeah.
Sorry, I'm just talking smack to my computer. Yeah, so I ran my predicted GBs, and that was nice. So now I need to add them to my transformed data set. Because right now they're just like independent, floating in space. I just saved them to a data sheet so that if I made a stupid mistake, I could go back and remedy it. So now I have, are those my ones? 124E07? What the heck? Oh, that's my trait too. And then predicted GV for trait 1. I got some like things that don't even look like they're really numbers. That's okay. So those are the predicted genotypic values. In your sheet, did you have predicted phenotypic values as well?
Yes.
And do we create those in R?
Yes.
So when I ran that code, did I create them and just not write the file?
So for me, it was the very last line. I can just share my R.
Okay, and when I ran that very last line, I thought that was my genotypic value.
So what's your last line say?
Write .csv bracket predicted GB comma and then whatever I wanted the CD to be called.
Okay. Yeah, I had.
But is that actually my predicted phenotype? Or?
No, that's your genotype. We haven't been running. We didn't run the code for this in 17. I think that's what's kind of hanging us up.
Okay, I'm just gonna blow this
So
up.
this would have been.
He gave it all to us in his.
Yeah. So I think what you're saying is this is where you ended right now, right?
Yes.
Yeah. So there's a
Okay, yeah, so
whole
the stuff that
other.
you shared here is
Yeah.
what I was missing, and that's starting at the hashtag write out original data, along with predicted phenotypic value, like in the chat window.
So compare pheno with predicted pheno. Did you have that part already?
Compare pheno with predicted pheno. No, but I'm gonna. Wait.
Okay. So this whole section is what's missing then.
Okay. This is good. I'm gonna help someone. I'm gonna pay this forward tomorrow. Probably.
So, Michelle, can you go back to that quick? I've got all the code
Okay.
Ah,
because I did have it over in a different
Mhm.
thing. If you could go up a little bit. So you've got. Excuse me. So you right. Yeah, okay, so Pred GB, yep, got that. Right CSV, got that. MU, that's exactly what I've got.
why does it do that when I try and copy and
Except
paste?
you changed it from train to data. That's the only difference that I see in here.
Oh yeah.
End train and end data. You have Y hat instead of Y mat. Again, I think that's just a... Because I have Y mat and Z mat. Why? Or maybe I want to make sure I don't screw this up. Although that's the way that I copied down the.
I think I need to put it in.
I guess that doesn't matter at this point in time. It's not going to interfere with anything because there's a Y. You have the Y vec. Y mat is fine. Main equals compare. Did you add that compare phenotype 2 with predicted phenotype 2? Or did you modify that? Because I didn't have that at all.
I put in a header, I think, or did
You
something.
put that header in? Okay.
Yeah, I think so.
Okay. And aside from Pred 1 and Pred 2, depending on which set you're running, right?
Yeah.
AB line, Pred, well, that's an AB line, it doesn't matter. And then can you go down to the bottom now underneath there? So, do that. I have a different file name. You have data, I have TRN. Pred Pheno, yep. Pheno null, yep. Head, yep. You put in the NA strings, okay. Just to run that?
Yeah, I don't know that you need it here. I just had it at one point when we were trying to get rid of all the NAs in the previous data set before removing them.
Okay, and then you just have one write CSV, okay, and that is. So why do you have that labeled as PS and GS? Is it going to give both sets of data to it?
Yeah, I could pull it up.
I'm just saying, I've got two different files that I could pull from. You have data. I want to make sure that I grab the right one to pull from.
Yeah, so this is what it returns. So it gives you your original, and then it doesn't give you your GB data. It just gives you the original and just predicted is all.
Okay.
So I don't know. I just left it as the whatever he had, and then just changed it to exam
Yeah.
3B.
No, okay, so you said it was your data file that you created data. And that, I was trying to remember what you had named data instead of, must be TRN for me. So what the hell, I'll just give it a shot. Now, did you run two of them or just
Yeah.
one? Okay.
Yeah, I pretty much did this whole process twice.
Yep.
One for each. That work for you?
So you have two files that you get out of this
Mhm.
for each one, or do you get 4 total files or just 2?
4 total files.
Okay, that makes sense.
Okay.
Because I'm doing.
And that's why I had just moved it all into my like data set
Yep.
that I was working out
Yeah,
of.
so you're getting basically a predicted GV and a predicted pheno.
Yep.
And I'm
For each
changing
trait.
it from CSV or text to CSV. Okay, I'll run through and take a look, and if I have any questions, I'll ask. Thank you very much.
Alright, I'm gonna stop sharing then.
Okay. Dang it, what was that?
So for the ANOVAs, you had to run like all whatever number of ANOVAs that was for the combos. You had to run them all once, and then run them a second time as mixed linear models.
We looked at the mixed linear models versus the,
Yeah,
and they didn't change really, so we kind of just.
like the values we need for the methods of moments didn't change.
Right.
Like you just get it presented differently.
Did you include like for A? Did you just do the straight ANOVAs
Yeah.
for that part?
Yep.
Okay. So I was wondering if we were supposed to do like data analysis on exploratory data analysis on that and realize, oh, we need to use mixed linear model like he was talking about, what that he did basically. But so I didn't know if we were supposed to do that or do it for both.
Sure.
I don't actually still understand how he decided that it needed to be like mixed linear.
I don't
guess-
either, and that's the problem that I probably should figure that out.
Maybe, I don't know. I was gonna say because there's correlations among the traits, but I don't know. Because then it's not necessarily linear if they're correlated. Yeah, I don't know. I don't understand well enough.
Yeah, no, I'm trying to think because the data set we're using only had specific families. Because I was thinking, oh, well, is it because it's unbalanced and you'd have half for some, but now we're only running it on the half we have.
Mm-hmm.
Yeah, I don't know.
Because I was just wondering if that's what he's getting at. Like, do some exploratory data analysis, realize that you need to use a mixed linear model, and then do that in B. But
Maybe that's his point.
yeah,
Maybe I just need to work with the mixed linear model because it wasn't giving me a lot of. Because that's just the Elmer one, right?
I think so. Yeah.
Yeah, it wasn't looking too different. I thought when I did it.
Not like when I copy and paste.
Play with it again.
I'm gonna go eat suppers.
Okay, Michelle,
Yeah.
this is what I got. You just have them listed as T1 and T2, right?
Yeah, that works.
I just had them as mine because that's the LS means. And there's the predicted phenotype. So I can just pull all this stuff. Did you, or, okay, I'll run my other one and then we'll worry about organizing after that. Because I know I'm going to screw that up.
Yeah, he'll do alright. I'm gonna step away for a second.
So, who has actually done their predicted phenotype for trait 2?
I'm still trying to get my code together.
I'm assuming Michelle's not back.
Michelle's not back probably.
Oh, and way to show up last night, Emily. Apparently Emily's not there either.
I'm back.
Okay, Michelle. So, the question I had for you was, for your predicted phenotypes for trait 2, did you get the exact same predicted phenotype for all of them?
I don't think so.
I got it's all 100.141 for every single rill for, I'm going to probably have to rerun that, I think. But
Let me pull it up and check. Hey, yeah, I did. There's a couple.
is it 100.141?
Yeah, pretty much. Some of them just were a little longer and had different decimal places, but looks like it's all variations of rounding to 100.141.
Okay.
Okay. And
I don't feel bad.
Found. Maybe I didn't create end data.
All right, so we have. Did you just put them all in one big chart, or did you have them in two different tabs? For
No, I put them in one.
so you have 1 and 2 together, right?
Yeah.
Is it just the predicted phenotypes, or did you? No, you brought over the other ones too. I mean, I saw what you did.
Yeah, I had predicted phenotype and the GB in there.
I've
And
got 'em.
then I was gonna bring the LS means over, well, either do the VLOOKUP and bring over that data into the original data set or vice versa, but the original data set is the only one we can compare to because otherwise we don't have LS means, right?
Mm-hmm.
For everything. So I'll probably just bring it into that table.
Why do I have this as 3? That doesn't make any sense. C is what that's supposed to be.
When you guys did the Novas, did you have a lot that were not significant?
For the individual family by environment, or
Yeah.
yeah.
Okay.
Yeah, the hint that Kyle gave last night, or he gave it to me, so I'm passing it on to you, is that the only one that has any significant difference in it, and he was going with 0.01 rather than 0.05. And I agree with him on it. It's trait 1, family F. All the others, there might be an occasional 0.05, but there's nothing better than that except for trait 1, family F.
Yeah. Did you add like a ton of graphs for that? Because he specifically wants just family and environment combination.
Yep. I just did phenotype 1 by family box plot, phenotype 2 by family box plot. Did them phenotype 1 by real and phenotype 2 by real box plots. And then I put in the ANOVA for family A, phenotype 1 and 2, and family or environment 1. I gotta write this down again. Phenotype 1, real environment, blah 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 blah. Anyway. Yeah, each environment, family A, phenotype 1 and 2 in environment 1, family A, and just to illustrate, there's nothing there. And then I did trait 1, family F, to just show, here's the only thing that had any significance.
Okay.
That's all I did. And then I'm going to just talk about how there was no significance anywhere else. I'm not going to show it. Here's the correlation of the two traits. And just discuss it, but there's very little variation depending on the trait. Built the model, did all that.
I think I see what I did. I think I chopped off a whole bunch of code. Yeah, that's nicer. You're a good little data set sometimes. Oh, it didn't let me do the Y hat T. It says that is a non-conformable argument. At first I thought it said uncomfortable argument, and I was like, oh, I'm feeling it. Y hat T Z mat at FM money sign U plus MU. Error in Z mat. Non-conformable argument.
But everything else ran just fine?
Well, this is as far as I got. Like, I tried to copy over the code you shared, and it wasn't copy and pasting. It was a freaking nightmare, so I had to put it in line by line and arrange it. So I'm just wondering if I'm still missing pieces. No, I should be good now. I created data. And now I'm creating a model, and then I should be able to move through these steps like I did last time. And I've got a non-conformable ZMAT. And it let me create it, but it won't let me put in the Y hat.
Okay, are your columns matching up right? To what's in your file?
Yeah, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. To 14, and then 15 is going to be a trait. So that should be fine. Yeah, I don't know. I'm tempted to close and reopen.
Yeah, it's always worth a shot.
I have a lot of, like, I didn't turn it off last night. I just left it running, so there could be crap in there from yesterday. Who knows?
This should not be this hard. Why is my brain not working?
So would I need to run all of, no, I wouldn't need to run that code again. It just moved down to the, I don't know. I don't know nothing.
Michelle, when you did all of your stuff together, did you keep all your marker data as well?
You're just talking like when I put it all in my Excel file?
Yeah.
I had just brought the information over to the original, so yeah, I mean, I still have all the marker information there.
All right, I don't know what I'm doing. I'm going to go and make supper for Lennon and myself, and then I will be back shortly.
Okay.
Okay, so now I created a predicted phenotype, and I'm not going to bother printing it out again because it did that already. So now I have to make another training set. And data, head, looks good, ZMAP, YVEC, MU, Y hat T, same problem, non-conformable argument.
Do you want to share? I can
Sure.
see if anything looks out of place.
Okay. Yeah, like I don't know. Should I just start from like the top of my window?
Sure, that works.
So I tried to tack on what you added to what Beavis had given us before.
Okay.
So there's like clean the environment, load the linear model.
You've got. Wait, which packages did you have? You had RR Blub.
Yeah.
I had LME4 also. I don't know that it was needed, but it was in his original, so I just kept it there. I feel like RR Blub is the one we're really using though. But
Mhm. Never hurts. And then there's this, which I did already.
you wanted 3 to 14, right? Not 3 to 11. But the brackets look right.
And then this
C.
Mhm. And the FM, and then Pred GV, and then Moo, and then Plot.
Oh.
So this stuff I did already.
Okay.
Then I've created the predicted phenotype. And then I wrote it out already. So I've already created this data set.
Okay.
And then there was this like second additional part, and this is where I'm starting to run into trouble. So I would still use the same data set that I used last time, so I don't need to bring that in again. And then end data.
Oh, so you already did this part, right? So you're just trying to do the second part?
Yeah, just the second.
Okay, so I didn't run this again. Or you're talking just get that second file, not the second trait, right?
Yeah, not the second trait. I need the second file. Like I have the first file produced. I need to produce that second file.
Okay, so mine, I didn't do any of the data stuff again. I just started with the MU rep part. Effect dollars in beta.
Are you kidding? And if I don't do that again, it'll be fine. And did you take that graph out?
Yes.
Okay. But this is phenotype 1.
Change the predicted phenotype to also to 1, because it should all be comparing within.
Export. Copy to the clipboard. Okay, so now that you're holding my hand, it's gonna work.
Hey, as long as it works, that's all that matters.
Kind of, yeah. And then write it out. So now I have for 1. So this is for trait 1. So now I have, just gonna take a quick PCs at what it gives me. Predicted pheno.
That looks like trait 2. Oh, wait. Yeah, that looks like trait 2.
Yeah, so because I've been pretty haphazard about this, this has gotten confusing. So you think this is trait 2?
Yeah.
Okay, I'll save it as that then. And Get out of here, little drop down menu. Okay, and just minimize that for now. Oh, because if you don't change this stuff, then yeah, I would have had it set up for. No. I don't really know.
It looks like it should be reading off 15, which, oh, yours is, trait 2 is your 15, trait 1 is your 16.
Are they swapped in name or in value? Only?
In your file, right
Yeah,
there
like-
where it's showing.
I see the headers, but I'm wondering if I just typed them in the wrong order, or if that's. Oh yeah, trait 1 is the bigger numbers, so whatever I
Yeah.
think is 1.
Yeah, because you just have to switch it to 16 for trait 1 to read
Yeah.
off that, yeah.
Oh geez. So this is so now this should actually be 2,
Yeah.
and this should actually be oh yeah,
2.065. I didn't think I had it quite that low. Let me check. For GV of trait 1, my first one was negative 8.5, but my trait 2 was 1.23 e to the negative 7.
Okay, so these might be wrong.
Why are they?
Maybe I should just run these all over again. Yeah, I'm wondering if I should just delete these and start again.
Yeah, might not hurt. Like your trait 2 one looks pretty close.
Yeah, I just don't trust them. So that's going to be the easiest choice. And then I'm going to switch them because that is confusing that they are backwards. I'll just delete these. Switch this.
So last night, did you guys change the way that you're calculating the average Lilith effect for each locus? Because I have totally different answers from what Jacques got, and I keep redoing it, but it ends up the same.
Are you looking in the whiteboard or on discussion posts?
Yeah, I was looking at that earlier, and then I kind of gave up.
Because I think we're doing them differently now.
So for the allelic effects, is that right?
I'm back for a little while.
Oh, for A, what's your value?
239.25.
That's it. So the formula was actually YAA minus the YAA plus Y big A minus parentheses Y big A plus Y little a, and then divided by 2. So before we didn't have the Y big A subtracting that average.
Okay.
What are you talking about, Michelle? Sorry.
The allelic effects and the A and D value. She was wondering why her numbers were different, and we did make that change last night.
Yeah, so it should be like minus 39.12 is where the allelic effects are as of last night.
Oh, that's not the blue one again. Let's see, too. So yeah, this is what we updated it to, and then yeah, negative 39.12.
Okay.
Yeah.
Okay.
So
okay,
just
so
this was the change.
Okay, gotcha. That makes sense.
Yeah. The equation we had before was actually the mid hetero or homozygote. It was like right above it in the notes.
Gotcha. Alright, yeah, because I had like everything else was matching and that was off, and I was so confused.
Yeah, that would do it.
Okay, thanks.
Yeah, no problem.
You guys get your grades yet?
Did he already post them?
He emailed me mine. For A, I did a few boo-boos.
Uh-oh.
I got a 90 or a 46 out of 50.
Okay.
Yeah, apparently I did the RR blup thing, so I'm a little worried.
I got a
Unless-
47. Oh.
You got a 47?
Yeah, I want to see if I did that wrong.
Yeah, I did the same too.
Oh, I got a nice observation on one part,
Well, good for you.
but a lot of red in other parts.
Yeah.
Ah,
Did we do it wrong?
no, on question 4, he told me you determined VG equal had the rep factor in there, and he said I shouldn't have had the rep factor. I asked him that specifically.
Oh God,
Don't blow
exam.
your top. Don't blow your top. Just remember.
Oh, so we also need to estimate the VR and CV for every combination before conducting ANOVA on combined data. So we probably need to do that for this one as well.
Wait, what was that?
So something he put on mine under the question 5, like I put a table of family environment combinations and like the p-values for each trait, and he said you also estimate the VR and CV for every combination so that you can tell if some assumptions about I think that was random numbers, I don't know, are violated before conducting ANOVA on combined data.
Yeah, I got that too. But I didn't know you wanted us to provide you the mean and the CV and all that information.
Mm-hmm.
Oh,
It'll be fine.
6, he said something different for heritability also. The phrase family and progeny mean basis indicates that the heritabilities need to be estimated from ANOVA of the combined data.
Mm-hmm.
But isn't that what I did?
Yeah,
Not.
I got the same thing.
Me too.
I thought for the combined, that was where I said all families.
Wait, what's happening?
Reading comments from exam A that he just returned.
Kyle's alive. Hi, Kyle.
Hey, what's up?
Having fun trying to decipher what we're doing wrong.
Yeah, I just got home, so this will be a great treat, I'm sure. I was super hoping I would have this weekend off, but now the weather cleared up forecast, and while it's good that we can plant, it sucks because I kind of wanted to have the first weekend off in years.
Would have been nice.
You know? Well, I got a good enough grade on the first part that I don't have to do the second part. So you can,
Yeah, so you can pass the class, is that what you mean?
yeah.
Yeah. Hey, did you, when you put your model in, did he change your model with some red lettering too? And it would be in, oh geez, which question? 5? I've got my model laid out and it's like all fine except for he added in one little part or changed it or something. I have to look in red.
For question 8, I put in a comment, I just said that I obtained the GB values using RR Bluff, and he just commented, good for you.
Yeah, he put a model in. It'd be good to provide a table of estimated VR, mean, CV, and VG for all combinations of families and environments. Is that what?
Yep,
That's what
yep.
somebody was just saying.
Same exact thing that
Yeah.
we got to.
Because
I got
we
a
did
very
put a
similar
table
comment.
of some data, and he wants more data that he didn't tell us we needed to run. So whatever.
You should also comment on the assumption denoted by error IID. I don't even know what that means. But
So who did question 8 correctly?
I thought I did. He just said I needed to explain that I used RR Bluff. Like he says, it looks like you did, but please explain that next time.
Yeah.
yeah, and I just like happened to mention that like I got these values with RR Bluff, and whether it's right or wrong, I don't know, but it says good for you.
Yeah, it says
I thought the
it,
same as Emily.
yeah, it appears that you used RR Bluff, but it's not clear in the spreadsheet. Okay, sorry, I didn't mention it.
Yeah, that's your predicted values should be obtained using R Bluff. It's like, well, that's pretty obvious. That's what I used.
Oh well. You have to
I guess
mention
it's
that's
good
for
practice. Like if you were presenting data in like a report or something, you would want to be like, "This is where these numbers came from,"
sure. Yep.
not just from like straight out of my ass town.
Do you guys get for number 9 that I said compare this with the square root of your estimated h square heritability?
But no.
Like for number 9, he wrote on mine, compare this with the square root of your estimated heritability.
He did not tell me that.
He did not tell me that
I
either.
didn't get either.
What do you have for your answers?
Just the correlation for
Yeah.
each phenotype.
Yeah.
Exactly.
Well, I wrote something too. I put fairly high correlation. Good to see after my heritability estimates seemed quite off. Also calculated correlation between GVs of trait 1 and 2 and got 0.42. Assumed that this would be more negative, but the residual variance may have also messed this up a bit.
I got no comments.
Yeah, me neither.
Yeah,
I don't know. My correlation was 0.775, and then he just wrote, compare this with the square root of your estimated heritability equals 0.8. Like, what, I don't know what that split. Why? What?
I don't know. You know, I'm just so ready to finish up 3B
I know.
and just be done. Let it rock and roll.
Yeah, like I'm doing pretty good. So like I can lose like 10% on my overall average here. So
And still pass or what?
and get my reimbursement.
Yeah.
Doing it for that reimbursement money.
I think I'm with Kyle. Let's just totally tank it after question 2 and not even do question 3 and just call it a like
No, I
the whole
can't.
class. The whole class does it.
I can't do that to Dr. Beavis. That would crush his heart. He worked
Yeah,
really
I
hard
know.
to rate this test.
I'm a bad person. I know.
Actually, let's see. To the grade section, I gotta simulate.
You have a simulated grade spreadsheet?
Oh no, in the you can simulate it on Canvas.
Oh, yeah, that.
Oh, if I don't turn this in 87.6.
Can you live with that, Kyle?
I'm so close to an A though.
No, we're gonna go to that point now. We're gonna just crush for an A.
What percentage is A?
Oh,
90.
What?
It's a 90, right?
No.
95, I thought.
Yeah, it's like 94 for him, at least on the syllabus. It's insane.
I thought it was 95 on the syllabus.
Yeah. It's
What? Yeah.
I'm gonna look.
Well,
Yeah,
you're
you
still-
make-
got
you
an
make
A
it right.
minus.
Oh, yeah. Sorry. Okay.
They'll be okay.
So I was looking
I'm
if
not shooting for.
I was
Where
gonna say
are you
we went
simulating it
from
on?
making an 80.
So in Canvas, Michelle, if you click on the grades that aren't in yet, you can enter numbers.
Oh.
If he actually gives me my 10 out of 10 on discussion 8 that he told me was a typo, because he put 0 out of 10, and I asked him about it, and I've already mentioned to him twice, and he said that it was a typo. So if
He'll do
if he ever actually gives me my 10 out of 10, then I think if I don't write this exam, this part of it, then I could still get an A minus.
Ooh, very nice.
Okay, yep, you're right. 100 to 95 is an A. 94 to 90 is an A minus. 89 to 87 is a B plus.
That's so high for an A, I feel like.
Holy
Yeah.
criminy, this is high. Yeah, this is the heavily.
Isn't it usually if like 3% for plus minus?
Yeah, it's usually like 93 and above is an A.
That's what I was gonna say. I thought it was usually 93.
Well, there's only two classes. This class and Dr. Singh's class last semester are the only two that weren't 90 and above or an A. They just used a straight up 10-point chunk.
Yeah.
There's
But
been others
everything.
that I've had that were, they did the A minus.
Yeah. This is
What's
the
the
only
whole range for the A minus?
94 to 90.
90.
I have to get a 19 out of 50 on this to get a 90 exactly in the class.
Wow. You're having fun simulating.
I wonder
Really?
if that properly like takes into account that the exams are like ×2.
I don't know if it does, but like
Yeah,
it seems like they're not all under the right. Like,
is it not?
Weighted, right?
I thought he put like what the points are out of. I thought it already was like in there weighted. Maybe
because,
not.
like look at discussion participation, and like it only shows that like 70 out of 70 for discussions. So a bunch of the discussions I think are being weighted under the assignment.
Oh yeah, that's a good point. But I think like
Who knows?
overall though, I don't think it matters because
It should still be pretty close.
well actually I don't know because assignments total points 330.
Though then again, our assignments and discussion like
Discussion was supposed to be 20% of your grade. The ALAs were 40%.
Yep.
Was it 20, 40, 40?
Yeah.
Yeah.
but like in the grading it has like an assignments, discussion participation, and then the ALAs. And so I don't know like
What's the difference between?
I don't know how they're splitting them between discussion or assignment or
Yeah, that's
ALA.
weird.
I'm with Kyle. If we don't turn this in, I still get a B plus.
Yeah.
Man, that is actually I should not have looked.
I mean, you could just turn in what you already
It's
have
gonna be done tonight.
Oh, I do have to
Oh my
hand
God,
in
what do you
this
say?
test if I want to get an A minus, but I only have to get 50%.
Well, here, let's see here. I can actually figure it up exactly because no, because they're not split up right. Darn.
Seems like the exams, other than the part A, I don't know where the part A is made. Oh, it's going under assignments for part A, I think.
Is it really?
Well, if you put your cursor over exam 3 part A, it says assignments on it,
Ah, that's not right.
but I don't know.
Yeah, who knows?
Oh yeah, and then exam 2, it says it's under exams.
Yep,
So.
yep. Part A, even though he's giving us 50 points for exam part A, he has it still in assignments, and it should be
ALA
down in
discussions
exams.
are under assignments too.
Yeah. And there's a bunch of stuff under assignments, even though we don't actually have assignments. We have discussion and then the applied learning activities and exams.
My father. Okay.
You kiss your mother with that mouth?
I'm trying to run the code, and I closed everything and
Okay,
started
that
again.
was fun, but
And then I got sidetracked by like Mark production. That was a fun little reprieve. So I got the predicted GV, and now I'm trying to run through the second half to get the predicted. I have one prediction. I need to run the second half of the prediction, and I'm getting weird errors again. Like there's just, I don't know what I'm supposed to run and not run in this code.
welcome to the club.
It worked when Michelle was watching me, but now it's not working.
All right, I have one question. Michelle, could you show me how you put your data together? Because did you do 2 different Excel files, one for trait 1 and one for trait 2?
No.
Okay, then I need help because my brain is not thinking linearly. It's been a day at work. It was It's nothing like having the dean of the college and a whole bunch of outside hostile interests to really do your day. Okay, so
So are you talking this one where I just brought in the 2 files?
is this what you're using for your calculations for D?
Doing the correlations was all right. No, I
Yeah.
did it over here. So this is the original phenotypic data, and then I brought in the trait 1 LS means. Well, I have the LS means, the predicted pheno. I didn't bring the GB over because we don't need it.
Okay.
And then I just did the correlation between the LS means and the predicted pheno.
Wait, you didn't. Hang on.
I love your predicted pheno. That makes me laugh every time I frickin' see it.
No.
Okay, but is this for question 2D? Because I'm just trying to. I'm just
Oh,
trying
no.
to.
2D, you need the original data set, and then the
Mhm.
GEBVs, and then you just. So, yeah.
So, yeah, the original data set, and then this is our GEBVs, right?
Okay. I've got all that data that you're showing right there. That's fine.
Wait, no, predicted phenotype's not the GEBV.
Mm-mm.
GBV is what we get when you run through RR blob, right? Because your because what you had, the predicted phenotype is the Alice means.
This came out of R, and this, so I got both of these out of R. And we had asked him tonight, and it sounded like we shouldn't be comparing this.
That's what it says.
Yeah, because,
Eh.
okay,
Okay, calm down.
Sorry, no, I'm not.
well, yeah,
It's like,
because that's what I was asking him, and I even pulled this up, and it sounded like, yes, we compare this with the LS means, is how I took it. Because I
Now, the
specifically was asking that, unless
The only
it
thing I
is
wanna bring
this
up,
and the
Michelle,
LS means.
The only thing I want to bring up, Michelle, is you asked him specifically
Comparing
about that
these.
question in A, and he told you and to divide by 2 or not. I can't remember what.
Oh, yeah,
I don't mean to bring up a sore point.
it's true.
you lied to you on a previous assignment or something.
In the last ALA, like we had gone over it in the office hours, and was like, oh yeah, we factored in the reps into how we had factored like the VG or something. And then in the comments, he said, oh, you shouldn't do that, and took that out. And I went over that in like the office hours last week, and that was what was it ALA 16? Like Boris had talked about it in the discussion, and apparently I'm still not learning anything.
Interesting.
Okay, so this is the sheet that you're going to work off of for doing D. Is that what you're telling me?
This is, but then I need to bring over the GV and I'll
GVs?
see
Okay.
what the difference
Oh.
is there.
You don't
But-
have environment in there, and that doesn't matter?
I have
And that
everything
one?
over here.
I don't see environment. You don't have everything. Dang it!
I just added into the original exam 3 the phenol file.
Okay, so I've got the whole thing to where it looks like you have it in a. Do you have it in a pivot table?
No. This was
Okay.
the original data set, and then I did VLOOKUP to bring in the data.
Okay, could you do me a favor and go down to environment 2 and see if you have. You're missing a big chunk of data, I think, because we don't have the. You have rep 2, environment 2, huh? What? Did I do something screwy with mine then? Because my data set for my LS means only goes down to the end of environment 1, rep 1.
So, I mean, my original LS mean, like there were
Mhm.
200 lines that came out of that, right?
Mm-hmm. Mm-hmm.
I had done VLOOKUP and brought in my LS mean last night
Mm-hmm.
over here. So I have LS mean for everything based off that VLOOKUp.
How are you getting 801?
This is the original file.
Well, yeah, but I mean with your LS means you only have 200 rows.
She added
But-
in all of them.
Yeah, I
Yeah, that might
brought
be-
it in. So I mean, there's 4 reps of the LS mean basically.
Oh, so you gave the 209.5 for real 1. That's assigned to all 4 of them. Is that right?
Yeah.
So each one will show 209.5.
Yeah, because I just
Gotcha.
I'm not
Gotcha.
working off the LS means file. I was working off of the original data set.
No, that's fine. I just copied it over. I don't have anything down below beyond that first set, and I'm assuming we need that. I'll deal with that in a minute. I gotta go deal with food.
Because I was thinking the only thing that changes here then is that you're comparing all your 4 different phenotypes to your LS mean that you're saying you
Mhm.
got for this row.
Mhm. Yeah.
Yeah, but-
Okay.
Okay.
Woo! Sorry.
Okay, so did anybody else for the 2D comparing the GV or the predicted pheno? Based on what he was saying tonight, what was your take?
I'm not
Because he-
there yet.
Okay, because he was saying a lot of people did the RR blub wrong.
What?
I think that it was because people were taking simulated data that they created, not data from R. That was my understanding
Yes.
of what the problem was that people just didn't get the part about running the RR block to get those values, and they thought it was something else.
Yeah, that's right.
And that's why, if you did do RR block, he give you a round of applause. So I think probably all of us did. Because we're hive mind. Okay.
Does everybody have a slightly positive correlation between T1 and trait 1 and 2, environment 1?
I had a pretty slight positive correlation between the two. I think overall, if I remember correctly.
Okay.
Across all environments, I had 0.03566.
Yeah, that's right. That's what I got too.
I guess I was just graphing it, plotting it.
All right, I'm back.
And you're like,
So if I already have all of my LS means in, is there a way? Well, and I've got them for both traits. Crud.
what am I gonna do?
Just trying to organize this nicer.
And the town.
VLOOKUP. Let's find out if that works. And to start VLOOKUP, you start with what you want it to associate to, correct?
What you want it to look up by.
Yeah, so the real is what I want it to look up by, so I highlight that first, correct?
That column, yeah.
All right.
There, I think I got that code to run. Look at me, I'm a regular hacker.
Okay, and I am switching my correlation to the GV, which is what I thought it was originally
I'm just
for
going
tonight.
exactly what it says on the assignment.
Well, yeah, that's why, because I was like, okay, are you saying the GV is not the GEBV or whatever he had in the,
Yeah.
Okay.
Negative.
Well, I'm going to go back to what I did the same as last assignment or exam then, since it looks like that was okay.
I have to do these from 2 different sheets, don't I?
Yeah.
You got it.
You can't. You can't do it in the same sheet, can you?
It would be
I
challenging.
suppose I could. No, I can't right now. I know what I can do. I can just copy and paste because it's all alphabetical or numerical. I don't know why I'm not thinking this. This is why I gotta be done soon. Because I'm gonna start doing really stupid stuff.
Are you losing your mind too? I went to back my car up at work
Oh God.
and I turned the key off. Like instead of shifting into reverse, I just like turned off the key. I was like, what the fuck am I doing? Like,
I thought you were gonna say you drove forward instead of reverse.
no, I just shut the car off. My brain was like, no, lady, like you need to stop.
My favorite part of all this. Go ahead. Sorry, I thought you were done.
No, that's it. I'm just flabbergasted.
No, I was gonna say my favorite part of all this is I'm doing stupid stuff like that too. I like have the key in my van and the van's running and I'm getting ready to leave and I'm like, oh, I gotta turn the van on. I'm like looking for my keys. Where the hell are my keys running? The van is running. Oh.
Keys are a problem. I couldn't find them in my purse this morning either. I was running around the house. I was late for work. And I was like, can't find the keys. They're in my purse. They were there.
Hey, good news. So whether you do it based off the predicted FINA or the GV, I got the same thing.
Good
Which
moment.
makes sense because we were seeing that if you compare the two, they're correlated 100% or like 100%, you know? So
Is
it makes
that
sense that it
good?
would be the same. I think so.
Okay, I got
All right.
key.
No.
I've got my little table.
I gotta go. Now food's ready, so I'll be back.
Have a good din din. I don't need dinner. We had catered lunch today, and I ate that and my lunch. So I had risotto and shepherd's pie.
Ooh.
I was so full.
My manager actually took us out for lunch today, and he was just like, "Yeah, this is a team meeting." And I was like, "I think you just wanted to go get lunch."
Hey,
How
that's
can you
fair.
say no if that's what someone needs?
I mean, you know,
Well, we have those business office people around all the time, and they seem to have a lot of catered food. So, like, they do have really loud phone conversations and, like, are extremely sociable. But they do bring a lot of food to the office. So,
You get the leftovers.
yeah, I might learn to love them and all of their food.
I don't know. So I think I broke, or
You broke R?
so I did like a plot, right? I did my first plot.
Mm-hmm.
And I was like, okay, I just went through and changed the number 1 to number 2, because that's all you gotta do. And then it's not doing it. Run. Work.
Run! That's some traumatic, like, gym class flashbacks. I don't like that.
What is happening?
In your R, though, for serious?
Yeah.
Is anything... Did you get the code to work at all for one of them?
Oh, wait, what is this? Why is that? Why are you a plus? Stop it. It's a plus now, it's not a command. Like at the bottom.
Oh, are you missing a part of your request? Usually when I've had that happen, it's because I'm missing, like, a parentheses, and it's like, I need more. Like, you didn't finish the command.
Maybe.
Eh?
Oh no.
That's the kind of silly stuff I get up to.
I'm stuck. Well, time to copy this code.
Yay!
And close R. It's like traveling through time, only way cooler. worked. That was a fun side quest. Are you guys fitting a line to your plots?
Like an AB line?
Like an R line? Or I guess it would be an AB line, yeah.
Yeah.
You are?
Yeah. Which plots, I guess, sorry.
The core, like the GEBV
Yes.
versus average pheno.
Yes, I did there.
How do you do that again?
So I just had AB line, and then mine, like the line above it was labeled Pred 1. So it just went off that. I'll just post an example. So that's all that I did.
Oh, I see. I see.
Correlation for T1. Oh, I could just put T. Put a header and then just like typed correlation a million times just for fun. Just to make sure I can spell. So.
Sorry, I didn't have my mic on for the past 2 minutes. Good Lord, I hate that. Okay, so is this what you got for? Is that what you got for your one, Michelle?
Yeah, looks pretty close.
And then 2 is a lot flatter?
Yeah,
Mm-hmm.
Okay.
Yeah, 2 is.
looks good.
2 is more loose. Those are my technical terms.
Okay, does that match? Generate a plot. Is that the GEBV versus the average phenotype, though? We're supposed to plot the GEBVs versus the average phenotypic values.
Yes,
That's them.
that's them. You got the same graphs as I did. And
All
this-
right, as long as that's them.
So,
I just feel so freaking lost right now.
so it's really the original data with the predicted phenotype, not the GEBV, right? If we're saying the GEBV
yeah,
is the
yeah,
GV. So,
Yeah, it's the original.
Never mind. Sorry.
because both the how did we do that?
So we're doing correlations between. I have to look at the question again. Generate plots of the GEBVs versus the average phenotypic value. Ooh. And report the correlation.
Divide the correlation by the square root of the estimated ratio from 2C. Well, one of mine is a negative
Yeah, why is that?
because it's not real.
No, I mean, when I did mine, and I thought I posted it, my correlation, I got 0.546, well, whatever, 0.55 for for phenotype 1 and 0.0046 for 2. Is
Wait,
that not
The
what you
correlation or your heritability.
That's the
Heritability.
heritability. Sorry. Heritability.
So, what correlation are you talking?
Yeah.
Oh, sorry, 2E.
Two E.
Oh, divide the correlation by the square root of the estimated ratio.
Okay, well, we can figure that out. Sorry, I thought you were saying you got something earlier that was a negative correlation.
No, I got a negative heritability.
You have negative heritability.
Yeah, I thought, didn't we all have negative heritability for trait 2? Which means it's not real. Like,
No, because we were doing VG differently.
Yeah, mine is just, it's low, but it's not negative.
how'd you do it differently then?
Because we did, so we were thinking the method of moments was the line minus the G by E. And then we divided that by the 2 reps times 2 environments.
Did you do that only for trait 2, or did you do it for trait 1 as well?
Both.
I see.
Oh, I did my correlation wrong for trait 1. I got 1. So it's not predicted phenotype.
Yeah, the LS means and
Oh,
GFV.
I need to move
I
it.
guess, why would you do G by E? Just,
let's see if I can find.
because if I do RIL minus my G by E for trait 1, that would be negative for me. Based on my mean squared.
Oh, really? What's your mean square for it?
970 for RIL and 1172 for environment by family.
Real by environment.
Oh, see, I didn't even have that in there.
What the heck? What are you doing your correlations to for that? Sorry.
Your LS
you were just
means
Yep.
and your GEBV? Or your GE?
No, not the LS means, right? It's the average phenotypic values. Or if you're talking about 2D,
Oh, yeah, because he specifically says the average, right?
yeah.
So that's your original values then.
The average original values, yeah. Where the hell did I stash those? Oh, those are over here.
Average original values, isn't that just the LS mean?
That's the same as the LS mean.
Okay.
Okay, but then how come I have more GEBVs than I have of LS means?
Because genotype had the full data set and your phenotype had half a data set.
Okay, so how do we
So we're
correlate?
only
Just
providing
correlate-
information for half a data set.
Okay.
Because we only have the original data for that.
So the LS means should just be for what, environment 1, rep 1? Is that what you're doing, or the whole set? And then I screwed that up. What I'm getting at is that I have to do a correlation between the 2 columns.
Mm-hmm.
Do you select all 4 replications of the LS means? The whole column where you've
I did,
got
but I
environment
had
rep,
brought
okay.
I did VLOOKUP and brought in my LS mean, so I had an LS mean listed for every single line.
Yeah, I've got that too. But I'm just saying, you did the entire thing rather than just using LS means once for that line.
Yeah.
Okay. Not saying you're wrong, I'm just asking a question. Believe me, I'm not saying
I
you're
need to
wrong.
do this VLOOKUP bit then, because what I did is not going to work.
Okay. And
I
I've
did
got
that. You could do it
one-
the other way because we're not using the original data, so it really is just off one LS mean and one predicted pheno, as long as you just have it in all in your file, right?
Yeah, I'm not sure that I do. So I just copied my LS means straight over. But that's not going to work. Because I'm not necessarily matching them to the right thing.
Can somebody pull up their 2C real quick for me? If I could just see
Is
that.
that the heritability one, or which one is that?
It's, yeah.
So this is what I had.
Okay, I'm getting an NA trying to do a
So-
correlation.
I did this minus this to get, and then divided it to get that value. Everything else is not needed, is what I was thinking.
So you didn't subtract your residuals out, you subtracted.
I did not, yeah. I have to
Okay,
look
well,
back at
my
method
first
of
one
all
is
that.
actually still really close, because you have 0.547, I have 0.533.
Okay, and you had just done this minus the residual, which makes
It's
sense,
pretty
it's pretty close.
Yeah. Then, hang on, just, so you're,
But are you dividing by the row, like the 2 by 2 also?
yeah, then divide by
Yeah.
4. Yep.
Okay.
I'm looking at here, sorry. I'm trying to reference mine back and forth, it's not going well.
Because are these the values you got then?
Wait, what's that? You know what? I did the sum squares for trait 2. I didn't do mean squares. That's why it's negative.
Ah, gotcha.
Yep. Alright.
Alright.
Thank you for showing me.
Alright,
That's definitely why.
I'm gonna ask for help.
Nope. Not allowed.
What the hell am I doing wrong? Excuse me.
I don't think you're probably in the same spot as me. I need to do the V lookup to get my LS means in so that I have one for each rill.
I have an LS mean for each rill. Did I screw something up?
Are you trying to compare two arrays that aren't the same length?
Yes.
That's not going to work then. I don't think.
That's what I was asking, because you don't have all the information in this. How do you compare the two rill or the two?
No.
How did you do it?
Are you still working on 2D?
Yes.
So you don't go off like your VLOOKUP file that has the lines that don't have the original average phenotypes. Does that make sense?
Kind of.
So you're only you open the original file that we started with that only had the 200 lines, right?
Okay.
You're talking the Ellis means one?
No, I'm talking the GEBV versus average pheno.
The average pheno one originally had 800 because there was 2 environments, 2 reps each.
Okay. Sorry, 200 different lines for.
Okay. Yes. So it pretty much should be this. You have that original file, and then you just do the VLOOKUP to bring in your Ellis means, your pheno, and your GV, whatever So you have values for everything in that file now.
Oh, so you're saying that the GV and everything's got to be V looked up to bring it all in?
Yeah.
So
And
nothing's
because
missing.
You don't have to
it
do
will.
it VLOOKUP, but
Oh, this sucks. Sorry, I shouldn't say that. That's not true. I just thought you could populate it and be done. No.
Yeah, so I don't know how to use the lookup because I'm in the same position as Jacques then where I have
Oh.
all of the values, but I need to populate them into my transformed data sheet.
Okay, so I'll show the demonstration, but thanks to Kyle
Yeah.
for reminding me how to do this after 10 years of not.
no problem.
So VLOOKUP, highlight the column. So first of all, you need to have the same column you want to bring data in your other tab. So we're going to match off this rill. So in my Geno file, I have rill set up, and then the trait that I want to bring in next to it.
Okay, so it's like how we do match update where you have two
Yeah.
identical columns.
Yes. So
Okay.
VLOOKUP. So now you highlight your entire column,
Yeah.
comma, and then you go over to your next tab, highlight the same column you're matching and the column you want to bring in,
Mm-hmm.
and then you could highlight multiple columns and then just tell it which column you want to bring. So it's column 2 that you're matching with. Since you highlighted 2, you want to bring in the second column of data, and then you have true, which is your approximate match, or false, which is your exact match. So we want exact, and that's it.
And then you can drag and drop that equation down.
Yep, and then just remember to copy and paste data, not formula. Get rid of the
Be
formula.
special so that
Yep.
it's not live.
Yeah.
Okay, I'm gonna try to do this. So, I don't like this. This is scary.
Yeah, no pressure, but if you screw it up, you screw a lot of stuff up. I mean, like for work, like I use it a lot for work, so I usually have huge files with like 20,000 lines.
Mhm.
And every once in a while, if you're not paying attention, VLOOKUP will just be like, and done working.
That's fun.
Okay, so
Can you bring
With
in
my-
multiple columns at the same time or just one at a time?
If you do index match, you can do multiple columns at the same time, I'm pretty sure. But VLOOKUP is just one column at a time.
Gotcha, okay. Yeah, we have this
I have
fancy
a
little
question.
match one update, and you can do match one, match two, bring in many. It's very handy. And yes, what's your question?
my predicted GV doesn't have the RILs next to it that it was predicted for.
What do you mean? Like your file you exported out?
Yes.
Oh, let me find mine.
I
Yeah.
just had a line of code, or a line, V1 and then a whole bunch of values.
Oh, like 1 through whatever?
Yep.
Yeah, in the second file I brought out because it had the same number, or you could do a VLOOKUP off the number associated with the second file you exported, like what I had labeled PS and GS.
Yep.
That also had a 1 through whatever. So that's how you match that up.
So the predicted phenotype file should have the exact same RIL setup.
Yes, that's my assumption,
As-
that they gave it a 1 through 560, so that is what I went off of. Because that's the only thing you have to.
I should be able to do that.
And if it's not, then it's all jacked up.
Okay. Yeah, it's all exact. So I'll just.
I want to match.
Okay, so I think I can. Holy crap! Figure this out. This is nuts. All right, let's try.
That's what I'm populating. And false because I want it to be exact. That did not work. Can you not talk between different spreadsheets?
No,
Yeah, you
you
can.
need to be able to. So,
So what's wrong with my thing?
because this one, all I did was highlight the column in this table. Then this one, I went over to that second tab, and I highlighted these two and put a comma after that.
Between tabs, but between total different spreadsheets.
Yes.
I think you should.
It worked. I just did it. Yeah, I just did it.
Okay, I did not do it. And then,
So, has anyone done 2E yet?
Dude,
No, not
I'm
yet.
trying not to barf here.
I just did it, and T2 has a value over 100%. So,
Hmm.
Is that bad?
So did you have the same correlation values as I have here?
let me look.
0.689 and 0.192?
Hang on. Where at?
Column Q over here.
No.
No.
Well, that's because I did. Which correlation did you do again?
So I did the Ellis means and
Yeah.
GB.
So that's why, because I didn't do the Ellis means.
So you did the average?
I'm going
But-
with exactly what it says.
So my average in the Like you're doing a pivot table average?
Yeah.
So my values are the same as my LS mean though.
No. Average phenotypic values. Wait, they're exactly the same as the LS means?
Yeah, 209.5, 195.75, 209.5,
I mean, yeah, because
195.75.
you're just averaging that column.
Yeah.
Yeah, no. So average phenotypic values is referring to the first data set that we use for problem 2.
So you're using this.
Uh-huh. Because otherwise he wouldn't call it average phenotypic values, he would call it predicted phenotypic values or LS means. Because earlier in the assignment when he says,
But that's not an average of it, it's the actual data.
no, that's the average across, yeah. Well, no. Are you-
Because, like, we have 4 different.
Hang on. I don't know then. I don't know why he would say average phenotypic unless he literally means take the. What the fuck?
Yeah, because that's why I'm thinking either your average by RIL, which is the same as your LS mean. At least mine is.
Yeah.
Oh, I don't know. We don't need a high grade anyway, right?
No, it's just dumb because apparently this is just not written very well.
And we haven't even gotten to 3 yet.
I mean, I'm just saying if I turn something like this in for work, would not be happy. Here, let me try it. Let me do a thing.
He's doing a thing, look out.
Okay, did you get your VLOOKUP to work?
I've gotten it to work, yes.
No.
And I'm tearing it up.
I did not. So I'm moving stuff into one spreadsheet, so it's just like less confusing.
100.141 never looked so sad.
Here, let me.
No. Pheno for trait 1. Pheno for trait.
Okay, what did you get for your... So, funny story. I took the average original phenotypic values, right, for the traits, and I got pretty much exactly what you got.
Okay.
Which doesn't make sense to my brain. But I guess if the LS means are, you know, I don't know. I'm not going to try and worry about it that much. It's good enough for me. But yeah, I guess, okay, so I didn't actually average mine the first time. Well, I'm going to throw this little table out. See you there.
Okay.
So LS means by GEBV, which is that one right there, it better be. I have a correlation of 0.69. Is that right for trait 1?
That's what I got.
Yay! Son of a god. This is like the class that will not die. And the second is 0.192.
Yeah, that's what I got.
Okay, calling it good.
I'm so
Okay,
confused.
so if I could get a hand with the VLOOKUPs, that would be good. 'Cause
Sure.
I'm having trouble.
You want to share your screen?
Yes, absolutely. Okay. Here's my spreadsheet, and then I brought these in here.
All right, so you have everything you need in the same workbook.
Yes.
All right, so go to your predicted pheno and your wherever you want the information to be into.
So I have a backup just in case shit hits the fan, and then I have this one that I'm
Okay.
working.
So go to predicted pheno, your first. Yep, and just enter evo and VLOOKUP. Yep, click on it.
Okay.
And then, actually, it might be easier. Well, yeah. So you highlight your real column, and then comma, and then do you know which tab you have to go to, right?
This is the phenotype one for trait one.
Predicted one.
Mm-hmm.
Yep. So you click that, and you highlight over, and hold your mouse down once you get all the way over. Yep, you can keep going. Oh, it's right there. Oh, sorry. Okay. Yep, and then you just hit comma again, and then 2. Because it's the second column, and then you want to look up, and then column again, and then false.
And that should be it.
Yep.
Oh my goodness.
Yeah. So when you're doing a VLOOKUP, just keep in mind column 1 is the literal first column in whatever you highlight for your lookup array.
Okay. So if I did this now for my genotype, I think this one is where things get a little bit crazy because these aren't going to exactly match because it just spit them out this way. Do I need to put real in front of them?
Yeah. So whatever file you use to upload to get all that, I just copied my real column because it should spit them out in that same order.
I getcha. Okay. Do-do-do. Oh,
So we're taking the square root of our heritability to divide to be the divider of, or to divide into the correlation, correct?
Oh, I forgot it was square root.
Yeah, but is that right? The square root of the heritability. Because he's talking about a ratio. The hell is that?
Right, the correlation.
Well, that's the whole question on 3C. He said, do the VG to VP ratio, and is that your heritability? Is what he's asking. And then justify it. Which heritability is VG divided by VP, so
Yeah.
by ratio, that's what he wants, right?
Isn't that, yeah, that's your hair, your
So, yeah, I said yes.
yeah, I did too. I said that the ratio does provide an estimate of heritability for each trait, but they are both very small. That's all I say. Right
Yes.
now. I've got it in yellow, which means that I'm supposed to think about it.
Yes. So then for, what are we on? E, F, F? E. Yeah, I was just doing exactly what he told us to do, the correlation divided by square root of those heritability values.
Why the heck is it? Come on, let me put that in there.
okay, I'll stop sharing now. I thank you guys so much.
No problem.
Did you get a estimated accuracy of 0.93 for trait 1?
Yeah,
Yes.
0.94. Close enough.
What?
And for trait 2, did you get, I got 2.7.
I got 2.83.
I got 0.688.
So do you guys have a bunch of no values in your LS means then?
No.
You can go and you clear them out.
Okay, but there is like a section with no data, or some sections with no LS data.
For LS means?
Yeah.
No.
No, because we're going off.
All your lines.
Yeah, you're going off the phenotype data originally, not the genotype data. So the phenotype data was half the data set that genotype was.
Maybe I did my LS means wrong then.
Wait. Alright, so how did you guys get 2 point something?
Hold on.
What's your trait 2 correlation value?
There you go. How's that?
Oh, here we go. Okay.
Okay, so your correlation was 0.192, which you had that also, right, Kyle?
Mhm.
Wait, say it. Yeah.
0.192 for trait 2 correlation?
Yeah, I had that.
Okay. So then it's going to go back to calculating VG differently, right?
Yeah, but I updated mine. I went back and changed that. So
To
my heritability was 0.07. You have 0.0046.
Yeah,
mine
I'll
was
go
pretty
back
close to that. I had
mine,
0.005. So mine was
Yeah.
based off of real mean square of 25.392.
Oh, that's okay. So yeah, this is where we get different because I didn't have that real by environment, and my
Yeah.
residual that for that
Just
was
subtracted.
23.4.
Okay, yeah. So
Yeah.
yeah, if you didn't have that other factor in there, makes sense. That would be the difference.
Yep.
So are you and I the same then, Michelle?
So it was slightly different still, but it's so I had my heritability of 0.005, and then the 1.92 was what I had otherwise. So I mean, I think it's just the difference in rounding.
Does that match it now?
Yes.
Yeah, I'm gonna go with my
Yeah.
ultra nerdy thing, but yeah.
That works.
All right.
So I think something's wrong with my LS means. How many LS means values do you guys have? Like I have 200.
That's right.
200 of them.
So if you're working with your original data set with 800 lines, I did a VLOOKUP to bring the LS means in, so it matched up with all 800.
Yeah, I'm doing the VLOOKUP and I was getting gaps. So I'll just try and do it again and maybe I did something dumb.
Should this estimate of accuracy be used in the genetic gain equation to predict gain for this subset of all lines? What do you guys think of that?
So I said, I think this estimate could be used for trait 1 due to having an estimate of accuracy close to 1, not for trait 2. And this is because my trait 2 one is at 0.68. I know your guys is over 100. I said this is especially considering that the differences in the phenotype of trait 2 are so small that only being 68% accurate would likely result in nearly no actual genetic gain.
So what do we do with having 283%? Maybe it can't estimate because it's too close.
Seems logical.
So you thought it could be used for trait 1 because it's close to 1?
Yeah, so if you have a 1 there, that means the square root of your heritability, excuse me, and the correlation between your average phenotypes and your GEBVs are exactly the same.
Right. So the closer you are, the more confident you can be in your prediction.
I think so.
Okay, I mean that makes sense to me. Yeah. But because, for trait 2, the GEBVs are super small. So I suppose with them, just like with large numbers, with small numbers, any small change could really throw it off.
See, this assignment's weird because it's telling us to predict the GEBBs of all lines from all families again.
Mm-hmm.
I'm wondering what's wrong
You
with
did
my...
admit to cutting and pasting on this, though.
Oh, gotcha.
My LS means have gaps where there's gaps in the phenotypic original data. So does that mean that I calculated my LS means incorrectly?
What do you mean gaps in the original file? Because the phenotype one didn't have gaps.
I will show.
Like the Geno did.
I'll show, and maybe I'm just doing something wrong. So this was the
Oh, yeah, you're going off the Geno. So you have all the families there, whereas the Pheno only had 5 families.
oh, shit. So I should be putting stuff into this.
Yeah. Because then you'll have a full set.
I see. So this can just go way over there, and then this is where I would want to have all of this.
I will be back shortly. I have to go pick up my wife.
Make sure you lift with your legs.
I know. Well, she's not very heavy either, so that helps.
I will just delete this. And then this. None of this needs to be here. This is all incorrect. Because it's no file. So I
How'd you do on part A?
satisfactory.
I got an 88.
88. Got a 90.
Nice, nerd.
So that means I can slack off even more this round.
Hey, I calculated it out. I have to get a 19 out of 50 to get a 90% in the class exactly.
Oh, you dog.
So now that I'm over halfway done with the assignment, oh, the pressure is just gone.
Damn.
Bet you Aaron still hasn't started. For like the past month and a half on Sundays, we basically both get on here Sunday night just do the assignments like together.
I was just say, like, every time I'm on the discussion, like, was it on like Monday or something? I wake up and he posts like all his discussions on there.
Yeah.
Probably at like 11:30. I'm assuming.
Yeah. Ooh, I almost closed it as Zoom. That would have been awkward. Oh my god, it's already almost 8.
I'm supposed to go to a friend's house in like 15 minutes, and it's like, I'm gonna be late.
Last night after I got off here, I was like, damn, I'm hungry. So I just went and got my truck, started driving, I'm like, and then there's an Arby's like right by my apartment complex, and I was like, you know it. I got 5 sliders and then a large milkshake on accident.
By accident, you mean
Yeah.
your
My
wild
order was small,
animals?
and they gave me a large.
Oh.
I was just like, okay.
Yeah, I'm probably not going to have a very healthy supper because I might have a cheese bun.
A cheese bun?
I have a bag of cheese buns. I don't know why I brought them in the house, but I did.
What's a cheese bun?
I don't know, it's like a bun that's got cheese baked into it.
Oh, okay. Yeah, that sounds pretty good.
Yeah, like nutritious, yeah. Caloric value, yeah.
I gotta remember how to do genetic gain. Why do I feel it's just the average of that percent minus the other average, right?
There was a selection factor in there, isn't there?
Well, yeah, but I thought the selection factor was them that's just how much you select. Because it's telling us what to select off of, too. We're not, like, estimating it. Oh, maybe, I don't know. Hang on, I'm gonna look at this. I know for estimating it, there was the factor.
So we don't have to run anything additional since we did it on the entire set. Like the other question, he just wanted us to do that on just the pheno? Is that what he was wanting? For D?
Hang on. I don't know.
Okay, I'd say we have the information though, so
Yeah, if you're going to F, you mean?
yeah.
Yeah, we have it all.
Apparently he just wanted us to run it twice, once for the half data set and once for the full.
Yeah.
So
Not
lots of
happening,
time.
Not happening.
Oh yeah, it is, like, realized genetic gain is literally just your average minus the beginning average. Also, on ALA 17, did anyone have a realized genetic gain of over 41.47? I saw a lot of discussion posts saying like mid-30s.
I don't remember. Let me look.
Because if so, that means I'm the best breeder.
No. Yeah, I did not. You win.
Swag. Wait, what did I do wrong? Oh. Crap.
Oh, I'm catching up.
Dang it. I thought I had a file with everything combined already. Apparently not. Maybe I deleted it in my rage last night.
So for the NAs and that you have in the genotype file, when you bring your LS means over, did you just change it to an Excel?
Sorry, which part are you on? You're making the file to upload, like the matrix?
Yeah, I'm on part D.
Yeah, if you're doing the where you have to upload that file, yeah. I just left them blanks.
Okay.
I can't find my LS means. Oh my god. That's cool. It deleted my file. That's sick.
No,
Good.
This game sucks.
it's a pretty terrible game. I'm not sure who designed it.
Is this true life right now? Oh, actually, no. I found them at least. They're not gone forever. Just mostly gone.
That's the wrong column. Cool. I'm glad I put that there. Okay, I got 0.68 for trait 1 and 0.19 for trait 2 for my correlation values.
That's what I got.
Those sound real?
Yep.
Well, those numbers that sound made up.
Wait, does this mean we have to do LS means for all of the entries, right? That's what this is saying?
You're on 2F, and that's what you're thinking. How do we make up LS means, though?
Dude, hang on. In 17, didn't we make up LS means? We would have had to have, right?
I don't think so.
No.
I think we
Like,
always
if we
calculated by
simulate-
R.
Yeah, if we simulate, like, that would mean we're simulating values again. Which, does he want us to simulate random values?
No.
For the other families? Yeah. Because otherwise we only have it for the families he provided us, and then we could calculate LS means, but...
Where did I save my stuff for ALA 17? There's only so many. Yeah, here we go. I have a notes page. Of course I didn't save my notes for it. God damn it, Kyle. Do have it in our history file though.
All right, I'm on E. Jesus, I thought that I'd finished question 2
No,
today.
it's the question that never ends.
Still 5 points left, and I need to leave soon. Estimate of accuracy. When true genotypic values are not known. So you guys are all working on E right now then, I assume?
Wait a second. This actually seems super familiar. We definitely did this in 17. Which data set do I need to use here?
And I'm back.
Welcome
It'd be
back.
nice if I could just stay here, but we'll see. Okay. I went back up to 2E, and the one thing that I noticed, or at least I put in there, I said for trait 2 it tells me the fact that the estimate is 2.83. Trait 2 it tells me that this would not have good accuracy, possibly because the GEBVs for trait 2 were so small, which they were, and the predicted phenotypic values were all the same. Does that make sense?
Yeah, I think so.
Okay. Moving on. Okay, so everything F, G, A, I, and H should all be from ALA 17, correct?
Oh, you did E?
Yeah, I just got done with E.
Okay. You just take your correlations and square root them?
No. I'll show you real quick.
Okay.
So you have your correlations here, and you have your heritability from 2C,
Yeah.
right? And so you take your correlation and divide it by the square root of your heritability.
I see. That's not so nasty.
And then you tell him whether or not it's good to use that and why, which is what we were just talking about.
Okay.
I'm assuming you're going to get weird numbers like I had.
Probably.
0.93, which is good, and 2.83, which is bizarro land.
So they're probably not good to use?
Probably not. And that's where I was saying, because the GEBVs for trait 2 were very small, and the predicted phenotypic values were all the same. So the accuracy is going to be off for prediction.
Core SQRT. This is a scary spreadsheet. I can hardly keep track of where all my information is. Which maybe is a testament to my organization skills. Relation divided by SQRT divided by heritability 0.923. I guess I'll probably get identical values, honestly.
Okay, has anybody figured out exactly what the heck he's asking us to do before we do F?
Yeah. So
Okay, what is he?
in the R blub script,
Yep.
there. So if you pull it up and look at it, you see where it says compare pheno with predicted pheno. Well, before that, we don't have a predicted pheno. So that first
Right.
up down to where it says y hat t when it creates that.
Yep.
I'm pretty sure that that creates predicted pheno, because the next thing is comparing the bits to.
Okay.
So I'm just trying to figure out which data set I want to run through it right now. Probably just the one before we even get the GEBVs or anything is what I'm going to use.
Wait, you're talking just about getting your predicted pheno?
Yeah, because you can't get an LS means from it from the normal way for all the other lines, because we don't know like what environments and all that other stuff
Yeah.
lines are from. Does that make sense? Maybe.
Yeah, I have the predicted pheno. But you're thinking then we just calculate an LS means off of the predicted pheno?
Wait, so you already got your predicted pheno by going through R.
Yeah, because I had the
Yeah,
predicted GV, the GEBV, and the pheno when I did it.
Oh, you did all the way through. I only did the.
Yeah, so Michelle and I, we both have the predicted GEBV and the predicted phenotype, right? That's
Yeah.
what you're saying, Michelle?
Yeah.
Yeah, because we ran them all through for both for both traits.
Oh, that's the predicted pheno. So that's why I kept getting confused when I saw your.
Gotcha, that makes sense.
Yeah.
Okay, so Michelle,
Yeah.
isn't this what we have? I mean, this is what we are. We already have all that information, don't we? Because here's my trait 1 predicted, my GEBV and my predicted phenotype, right?
Yeah.
Okay. So we already created what he wants. That's kind of why I was confused.
Yes. So I'm guessing for 2D or whatever, like, his assumption was we were only doing it on the pheno file, even though we were already talking about the genome file.
Mhm.
Since we were only comparing that, is my assumption, and he just didn't think about it all the way through.
Okay, so what's the GEBV from the phenotyped and unphenotyped? No. Okay, got it. Into a single file and sort using GEBVs.
So basically,
This seems simple. I'm scared.
No, don't be
Sorry.
scared.
Yeah.
Go ahead.
It's the whole point of analyzing the data, right? Look at
Yeah,
it.
it's
I'm
easy.
terrified. I'm
This is
terrified.
It's easy.
It's all in the data.
I can see the numbers, man.
It's full of stars. Who gets that one?
Nope.
Anybody. Oh, God, I'm old.
Nah, it's fine.
For next year? Hey, I got good news. Both of my kids just got $4,500 scholarships for next year.
Oh, nice.
It's not bad.
For high school?
For college.
Oh, for college.
Both of my daughters are in college.
Ah.
My son, on the other hand, was not happy with his ATC score. Or ACT score.
Oh, ACT. It's back memories.
So he's going to retake it.
What did he get?
25.
Don't mind me asking.
Yeah, he got a 25.
Oh yeah, that's like borderline of like pretty good and just like
Yeah, his sisters, his oldest sister got a 30, and the middle sister got a 31. So
that's pretty good.
he's kind of sad.
competitive.
Well, I don't know if it's he wants to go to Northwestern to do economics and business, so he wants to do better.
He's got more gumption than I did. Although I got a decent score my first time I took it, so I was good enough.
And I took it long enough ago that they actually they changed it since then.
Was it raining on
If you guys remember that or even heard of that.
When they changed it.
Yeah, so it used to be the ACTs were set up one way, and then like just to date myself enough, I think back in like '93, they added the written portion and they reweighed it. And then everybody's asked, well, okay, if you took it the old way, how does that correlate to a new score? How do you compare the two? And the last I remember is you add 2 points. So whatever you got prior, you add 2 points to that, and that gives you your score. Yeah. It's that kind of crazy crap that goes on.
Quick question. I ran my T2 predicted phenos are all the same.
Yep.
Oh, is that okay? Just making sure that I wasn't like the only one.
Oh, mine are all 100.141.
Yep.
All the way down.
I have really long decimals, so there's a bit of variation in mine, but they all round to the exact same thing.
Oh, good. Let's all be wrong together.
Oh yeah, I guess there is a lot of decimal changes in mine as well. I see that now that I've
That are really irrelevant.
No, those are huge, dude. That's quantitative breeding, man.
It's gonna change everything.
How much longer do you guys think you're going to be picking away at this?
I don't know. I wanted to
All
be
night.
here already,
Okay.
but I'm so close to the end. I might as well just finish it,
Yeah,
and then I never have to do it again.
it's true. I was assuming that I would be here all tomorrow night working on this. I need to leave soon, so I'm wondering if anyone else is going to be around tomorrow night.
I will be.
And Emily, you saw the note that I can do study session for 523 at 5.
Yeah.
Are you going to be there?
I should be. Depends on how far I get on this tonight. I'm a little bit behind everybody else.
Okay.
I logged on last night, but I was an hour late.
What is genetic gain? No, that's
Oh,
fine.
you were on late last night then.
No, she got onto the study session
Oh,
for the other class
class.
an hour too late. I was on there for half an hour and nobody showed up, so I just switched back over to here. So how did you guys answer F? I've got to stop talking and start paying attention.
I'm still getting my tables all sorted out. So, answering F should be.
I'm trying to remember where that table is with the selection percentage, like the factor you use.
Oh, that's the one that Chelsea found, and we had to use
Yep.
that like arbitrary value.
Yeah.
Yeah.
remember where that's at.
Yes, I just saw. Is it in the modeling? Simulated models of GPU effects?
Selection, heritability, and genetic gain.
That's in there?
Think so. 2.67.
Is it correct?
Yeah, it's a good question.
I don't mean to be a smartass, but I gotta be. Yep,
Better be
it
a
is.
smartass
Page
than
4. Selection, heritability, and genetic gain, page 4, I believe. Nope, I'm wrong.
No, yeah, that's right. Isn't it? Like the frequency selected there, that table?
Yeah.
Yeah. Because for 1%, we used the 0.01, the value was 2.665, we used 2.67 in AOA 17. So, what are we looking for this time? 5%?
2.06.
So I was right. Okay. Where the heck did they pull 2.1? Okay, I gotta go through this for a second. Here's the height. I got it.
Let's see.
It's just based on RPE. Got it. So we have to calculate it, right? Is that correct, Michelle
What?
or Kyle? We have to calculate what this number is going to be because it's z divided by p, and p is what is.
Z divided by P, what?
I'm reading on page 4. How do you get that correct number?
Oh, it's in there. It's in that table.
It's like a standard.
The truncation point?
Yeah. So if you actually, those numbers also are, if you remember just like base stats, it's confidence level. It's the same t values for that level of confidence. That's why 1%. Like when I saw 2.67, I was like, that seems really familiar. And
Yeah, but 2.67 I don't see in the chart. Is what I'm saying.
2.665.
Oh, I'm stupid. Don't mind me. God. That kind of stuff just pisses me off.
No
I don't
worries.
know why I'm that blind. I'm kind of double checking all this to make sure we get this straight because if there are numbers. So I'm looking 5%. It's 2.06 on the T chart, but up in the writing he has I equals 2.16.
What was talking
For
about?
upper 5%. Now, I'm not trying to be a dork.
do you think he wants a standardized selection differential?
Doesn't specifically say that, but
Because if so, it's literally just the mean of the top 5% minus the overall mean. Because under selection theory on page 3, it says selection differential is defined as S equals X of S minus X P. So I assume X of S would be mean of selection minus mean of population. Maybe not. I know, because when we did the predicted gain estimates for ALA 17, we didn't have like LS means for everything, right? I'm pretty sure we didn't, because
I think we could have because we simulated phenotypes for everything.
yeah, but I thought we calculated that like really.
So we just sort everything by our
No, you're right.
GEBV, right?
If you predict 1% of your lines based on LS means to create blah 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 blah, what's your predicted gain? You're right.
You're just sorting everything from the, and it would be the GEBV, right?
Yeah.
You sort that by that, and then you take, what's the top 5%? Do you know how many that is?
So here you go. To get the same genetic gain estimation like we had in ALA 17, sorry, is your phenotypic variance times your heritability times your that selection coefficient, so which is like 2.06.
But it's the square root of both of those, isn't it?
So, square root of your variance only. So it's your standard deviation times heritability times. Yeah.
So you're saying it's a square root of VP times H times whatever the selection coefficient is.
Where are you looking at that?
I'm just going off my assignment.
Oh, okay. Because I had it marked as square root of both of them. Don't remember if that's right.
Yeah, he didn't say anything on my answer for that either.
And where the equation is.
I'm looking. All right. The square root, this might be what you're thinking of, Michelle. We were figuring out the delta G, and that's the square root of the narrow sense heritability times the square root of the genotypic variance times our selection pressure, our selection intensity. Is that maybe what's making you think about that?
So what's delta G?
That's your genetic gain.
Isn't that what we're calculating?
Okay, stop making me feel stupid.
Well, like
Okay,
we're
so here it
calculating
is, just so you
predicted
can-
genetic gain, right?
Just so
Yeah.
you can see it, yeah. Just so you can see it. This is what we got. This is the formula, but it's narrow sense heritability. Do we have that?
Yeah, that's what we calculated early on in the
Okay.
assignment.
I thought that was broad sense heritability. Don't mind me. I'm just
Well-
by letters and not paying attention.
Well, no. So broad sense is. Yeah, that's what you have is broad sense right there, right? Isn't broad sense
No, this is narrow sense
phenotypic
heritability.
by genotypic? I thought narrow was additive variance by.
Yeah.
Oh, I don't know. Maybe this was where broad. Not saying nothing. Just keeping my mouth shut because he okayed it all. That's Luke.
I think that's the hardest part where, like, you okayed everything, even if it's not
Mhm.
right.
Yeah, it's like, okay.
Mhm. So
Okay,
is this what you
so-
were thinking of, though, Michelle?
Yeah, because we did do square root of both.
Yep. Square root of both times the.
But I can't find the equation for that.
Wait, so what were your actual gains then in that assignment? Were they all like that low?
Yeah. But
Really?
that's question 8. That's after that's the third modeling.
Were yours really high?
No, so my predicted gain overall was 35, and then my actual overall was 41.
There's a delta G back on question 3 that was in
Yeah,
the 30s.
That's what I'm looking at right now.
Yeah. And that's still the square root of those two times I. I just happened to be on question 8. Michelle, you're looking for the formula that is. I just saw it not too long ago. It's on page 5 of selection, heritability, and genetic gain at the bottom. The R with the dots in front of it equals H squared S equals I H squared delta P. Equals genetic gain sub C. I don't remember the square root portion, but I do remember us discussing it and then saying, yeah, it's got to be that.
I'm gonna take off, but I will talk to whoever's not done tomorrow night. I'll be on at like 5 o'clock.
Sounds good.
Be on, but it'll be a little bit later because I have to go on the thing for our other class.
Oh, that's fine. Well, I'll start chipping away at stuff, and whenever you're here, you're here.
Okay.
All right. Thanks for your help, everyone. Have a good night.
Yep. See ya.
Yep, you too. Thanks.
Bye.
Oh, I saw your file and I thought you were simulating, and I was like, how much have I missed?
He changed everything.
So
I'm behind, but
for a 5%, it's 2.06, correct? Is that what you're going to use for the
Yeah.
selection? Okay.
So then we really just do 2.06 times the heritability times the genotypic or phenotypic variance. Is that right?
Yeah. Well, I'm doing it with square roots because that got us what we needed. Right? I'm okay.
You
reading
can't tell us it was wrong.
The predicted genetic gain for a 5% selection differential based on LS mean values.
So you could do this 2 different ways, I think. You could, because at first I was just going to take the top 5% by sorting for LS mean.
Mm-hmm.
Average minus overall average. But if he's looking for the predicted genetic gain formula that we've been using,
Okay, let's ask this real quick. Do we want the largest or smallest number for LS mean?
What do you mean?
Well, when you're sorting your LS mean, to get this, do you want the largest value for LS mean or the smallest value for LS mean? I'm assuming for phenotype 1, you want the largest because that's based on yield. We know that. But for marker score, what would you, for trait 2,
I
what would
think
you
you'd
choose?
want.
You still want the largest. Because
Okay.
that's the positive impact basically on your overall phenotype, right?
Well, this is the LS mean, but yeah, I'm just playing devil's advocate here.
Yeah.
Depending on the trait, we might want either, but he didn't tell us specifically, so I think assuming that we want the highest one is fair.
And so 5% is, we don't need to select it though, do we? Because we're using the whole LS means and then we're applying that. We just need to know the LS mean values for trait 1 and trait 2, right? Sounds like we just take it. Is it the average of the LS means that we base this on?
Like, for comparing against your population, you mean?
Yeah.
Yeah. Yeah, because we don't have phenotypes for, or most of them, like actual phenotypes, so you have to go off the LS means. I guess you don't
Yeah,
have
I'm just trying to build this model is what I'm saying.
Yeah.
So if we have our LS means, we just take the average of the LS means times the, so I mean, okay, I've got I. We know what that is. So that's not an issue. That's 2.06, so that's already in. The question I have is, do we want? Are we trying to say we're going to go with VP and H because we don't have VP? VP would have to be the average of the LS means, right? Because we do have the heritability.
Yeah, I'm using, sorry, I keep, like, zoning out to try and...
Yeah, I know. The only reason, yeah, because we have, as far as I can tell, we don't have a VP anywhere in our calculations yet at this point, anywhere, right? To go back to.
VP is just
Not-
our.
Yeah, not for LS means, but I mean, I'm just doing it real quick, like with a pivot table.
So Kyle, you're just
Oh, we
doing
do have
I
VP.
times the heritability times the VP.
Yeah, let me look at mine. So what I did in ALA 17, I took the square root of the VP and then just the heritability and just the thing. But let me test something real quick. So if you want square root of that. Now it's possible that because my heritability, like the heritabilities were so high in ALA 17, that me not square rooting the heritability didn't matter. Know what I'm saying?
Mm-hmm.
So, so you said in the notes that it says you should do the square root of both.
No, I don't see that. So it says R equals H squared S, which is also equal to I H squared the omega or whatever P. So I times heritability squared times the phenotypic variance. But is the H squared or is that narrow sense heritability? I'm going to assume H squared.
Yeah, go with that.
I don't know. YOLO.
Yeah, exactly.
I guess I'm just going to do the exact same thing I did on assignment 17 then.
Yeah.
Sounds good to me.
I don't know if it's right or not.
Just get this shit done.
Yeah.
I'm
Everybody's point.
I'm so with you guys. I'm almost ready to cry. I just want to be done. I just do. I'm so tempted, Kyle, to just go, you know what? 88% is good enough.
Okay.
Also, if you're doing your VPs, are they almost the same for your LS means and your GEPV?
No.
No.
Oh, I have only done my, for my LS means.
Oh, yeah. Let me know once you...
Okay, I'm trying to finish up this so I
Just
can have you
to
guys
check.
tell me if it's square.
For your LS mean, so you're still only doing this off of the original phenotype data, or
I'm
are
doing
you
it
averaging out based off the predicted pheno?
predicted pheno.
Okay.
So I did average per entry, but I mean that's what it's in already. But I just did it just be safe, and then I just took the variation of that.
Is this what you guys are getting for your LS means?
Where
Okay, well, my LS means, that's what I got from...
that's your
So-
variation.
Yeah, that's my variation of my LS means.
But is that still off the original data? Not
That's from
like the Pheno file.
No, I got 93.6. Are you doing that based on entry mean, or is that just off a straight
entry mean.
or entry mean? Oh, yeah, I definitely don't have that.
The var S of the entry mean. So this is from 2C. That's my VP.
Oh, so that, all right, so yours right there, that's off the original Phenos,
Right.
right?
Yeah.
Yeah, I'm not using that.
Why?
I'm taking the variation of the LS means because it specifically says differential based on LS mean values.
Okay, so you're just doing it off of this right here.
Mm,
Even though we have all of those LS mean values knocked in there and all that stuff, right? So you're getting I'm getting a 244,707 variation.
No, I'm taking it for all RILs.
Yeah, I just did all of them.
So you
All
are you saying you
800.
created an LS mean based off your predicted Pheno, so you had it for all families represented in the Geno file?
You asking me or Kyle?
Kyle?
Here, let me screen share and I can just show you.
It,
Like by all reals, is it all families, even the ones that we didn't actually have LS means, and you're generating that from
Yeah,
what we got? Yeah. Okay, that's
No.
what I was doing too.
yeah. So this is the Geno file. Like you can see
Yeah.
there's gaps in the normal.
Yep.
Phenos.
yep.
So I loaded in my predicted Phenos for every single line.
Yep.
Right.
and
Yep.
Pivot
And
it.
then I did a pivot table.
Yep.
And then, but I made sure I was taking, that should say average. I don't think it changes anything though. For that one anyway. And then, let me throw the guy. Okay. Average of T1 predicted Pheno.
Yeah, how come you only have 500? Because it knocked a bunch of stuff out?
Doesn't it only go up to 500?
I've got 800. 200 per rep, 2 environments, so 800 total.
What the fuck? Oh. So I'm basing this off the Geno file, which does not have every replicate in there. You know what I'm saying? So here. So if I filter this for...
This is where he just told us to make a combined file of everything.
Mm-hmm.
So if I took out the blanks, I have 200 times 4 would be your 800.
Right.
Yeah, so I'm not missing any. But I just don't have my environments. I don't have all that stuff in there. How I got these, I just basically ran this back through. And then I'm just using these to figure out a new variance for those estimated.
Okay, we have the same predicted phenotypes. Sure.
Yeah.
It's just the LS mean. So I just went through and I put, like Michelle did, I assigned every RIL, and every RIL got an LS mean value in every environment and every rep, which means that, like, for environment 1, rep 1, or for RIL 0001, there are 4 LS mean values for it. And you're saying that's not correct. Is that right?
Yeah, I guess I'm confused. I guess I was doing it based off the predicted Pheno.
Yeah, so going back to the Geno file, everything we exported, we got predicted phenotypes for all the RILs.
Mhm.
and then just creating a pivot table and averaging that out, which would be the same as our LS mean pretty much. So now, where we were previously missing LS mean in the pheno file, we have LS mean for everything.
Exactly, yeah, because how we actually get the LS means, I guess you could go back and you could put in, environment A, blah, 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 you could see what it looks like, but this predicted pheno should be your LS mean, basically. Unless I'm crazy, unless I'm way off here.
Just want to make sure that I'm understanding where you guys are going. So I got to open up a different file as part of the problem here.
So Kyle, did you get 93.6 and then 8.05 for your phenotypic variance? When you did the VAR, well, I did VAR S.
93.6, yeah, and then what was the other one?
8.04.
Times e to the negative 15th?
Yes.
Yeah.
Yeah, that makes a difference.
Yep, and they were like the same for LS means and GEBV for me. Or like, they
Yeah.
weren't exactly the same, but they were close.
Yeah, that makes sense because they're correlated. Like they're simulated off the exact same thing.
I mean, I don't... Yeah, I don't know if that's right or you need to go with the literal LS means. But to me, the whole point of this question is for us to just look at this and be like, they have the same variance, phenotypic variance between the two. And it's cheaper to do the DNA extracting.
Yeah.
Oh.
So
That's what I'm thinking.
oh, never mind. I was gonna say, but we don't have all the information for heritability, but just use the heritability we have anyway, and call it good. Because we don't have the information to do heritability for the others. So use exactly what we calculated for.
Yeah. Unless you somehow do another ANOVA with
No, I don't want to.
don't have.
Yes, exactly. Excellent. I will finish this up.
So I'm screwed up. I can't find the file that you guys have. Insofar as where's this at right here? So you're basing yours off of 561 entries. Oh, why in the heck is this so stupid hard? With the blanks in some areas for the LS means of trait 1 and the LS means of trait 2, right? This is the file that I used for the R. Are you using that as your base file? The one that you fed into R to do all your predictive modeling.
Give me just 1 second, sorry. I need to...
I basically am using the file that I got out of R with the predicted pheno in it. And the GB.
Okay. Because I did not... This is where organization is important, dang it. Because I've got it all by LS means in there and all my predicted values, but the problem is that I went and did the look statement. Sorry, I don't remember the one where you brought the values in for each RIL.
Yeah, I mean,
Find them.
so that's what I...
All I'm saying is which data set should we be using? Because I've got the one data set that I'm trying to work with is the one that has all the entries, so all the LS means have a value, or all the RILs have an LS mean value assigned to them, all 800 do. You're saying you're just working with the ones that had predictive phenotypes and the ones that didn't have.
So
Or,
you keep saying 800. So it sounds like you're in the original data set. Only the 200 that we had actual phenotypic data for that's replicated 4 times. That's why it's 800. It's the same 200 4 times.
okay, that's not how. Okay. The problem I'm having is here. I'll just go with this. And this might help.
Okay, so the file you have only has 5 families, right? Not 7?
Okay, no, hold on. Here's what I got out of R. This is my trait 2 predicted genotypic values, right?
Okay.
From that, I've got 561 entries, or 506 entries. Obviously, there were some gaps, but I have that. Now, the original data set with all the replications and environments, there are 800 entries.
That's the phenotypic file that has 200 RILs, 4 replicates.
Right.
Yeah, so let me just share what I have. Okay, so I had one file that brought the GV, and then another that brought in the predicted phenotype for both traits.
Yes.
So I just took that second file that had the predicted phenotype in it, brought in that GV, and then brought in trait 2, and that's the file that I'm working off of. So I've got 560 RILs from the Geno file, and brought in those 4 files of data we got out of R. And then, so I don't have the LS means here, because we don't have it for everything.
Right.
Created the pivot table off of this, and just averaged the phenotypic predicted.
You're just working off the phenotypes. Okay. Because
Yeah.
I believe I had created a file just like yours, and then I believe I ditched it.
Because, I mean, this would include all the families now. All the RILs, which is what we needed. I mean, the only other thing is if he really wants LS means, if we use the original LS means, but we don't have it for everything, that's why we...
Okay. Family, blah, blah, blah. Trait 1, predicted phenotype, and trait 1, genotypic value. And that's it. And then obviously your RIL. But...
Yeah. I mean, I don't know, because we don't have multiple replicates or anything here, so really it's not an average, it's the actual value.
Yeah. When I kept saying average, I meant when I do the pivot table, I change it to say average, not sum. Just
Yep. But, I mean...
I'm okay with changing this over and creating a whole new file so that I can work in, because I've got, oh yeah, see, I've got the file with the trait 1 LS means and the trait 2 LS means, and then all the NAs are in there and all that stuff. And we don't want that, right? At least that's not what you guys are talking about. This is for...
Yeah, I got the exact same values too, Kyle. So, I mean, does he maybe really want us to go off the LS mean even though we don't have all the data? I don't know what the point of all that is.
I mean, it's entirely to set up INH, I'm pretty sure.
Yeah.
That's what makes sense to me, at least. I mean, I don't... Oh my god.
Okay, so just take a quick look. This is what you guys have. Predicted phenotype, genotypic value for both of them, and that's all you're working with, right?
Yeah, that's what I'm using.
Yeah.
Okay, and then you just turn this into a big old nasty, I shouldn't say it that way, that's not true. Pivot table. Like that, and then you do it by, how do you set your table up? Rows, columns, and you did cred value there, I'm assuming. And then I believe rills down the rows. And that's it?
Yeah, I put both
And then you do
on and
average?
two. Yeah. And then you could pull in the second trait too also into the values and have two columns.
Like that.
Mm-hmm.
And then and then where do I go from here? Take an average of all that, is that right?
Yeah, if you do the var
The
S.
average,
you
an
get your
average of the
phenotypic.
averages. No, it's the var S.
The var S to get your phenotype, yeah.
There we go. You end up with 93.6?
Mm-hmm.
Yeah. And this is what we're calling and 9.5 to the eternally small. 9.055 E minus 15.
I had
See that?
8.05, but yeah, it's so small.
What did you have, Michelle?
I had the same as Kyle.
You had all these 100.14s?
Yeah.
What the heck?
So, question I is not worded very well. Because if you... Maybe he's saying if you put every single line in 4 plots. Because if you just do $25 times the 800 plots you actually have, it's actually more gain per USD for the plots. Which is probably not what he's trying to show there.
All right, so
Oh yeah.
what you guys? Okay, so for what you guys end up getting for delta G then? 14.73 and 1.33 minus 8 minus 0.8.
What was the second one?
Right there. 1.3307 to the minus 0.8.
That's not what I got.
Is this ballpark?
So you did the square root of both, right?
Yeah, I did the square root, but remember, I had different
Yeah, heritability.
heritability.
How about you, Michelle?
Just,
Are yours similar?
Well, I mean, that's what happened.
yes.
Well, they
Okay.
won one.
So we're through
They were the
F.
bottom. Yeah, everything.
There's no way this is legit. Oh, because that's not the right thing there.
Did you just report the delta G's, or did you guys do more than that?
I just reported the predicted gain, and then I said based on what it was based on.
Well, that's the delta G, right? Genetic gain, predicted genetic gain, right?
Yeah,
Based
yeah.
on the predicted values, okay.
And all This is your control. But you want to yeah. Get the wing at least 60.
Okay, yeah, that's why he had $25 and 4 reps. Yeah, that makes sense now.
Because
Moves exactly 1 decimal place. So you're 10 times more effective with your cute Beavis. Very cute.
man, you are just so dang fast, Kyle. Holy crap!
Thank you.
I can see why you wait till Sunday night to do this.
Yeah. That's not why, though. It's mostly out of laziness.
Well, I mean, you can get away with it, is what I'm saying. All right, so based on GEBVs, did you do the same thing, but just with GEBVs for your values?
Yep.
With your pivot table?
Oh. Playoff 3 right there. Okay, so. Everybody is seated from 1 to 51.
And again, 93 and 8. Well, I got 8.04 for my GEBVs, Kyle, not my LS means.
Hang on.
Maybe that's what you were referring to.
8.04 for your GEBV. For trade.
Yeah, to the minus 15, yeah.
Yeah, I got that for both of them. For the LS means of trait 2 and the GEBV
Yeah.
trait 2.
I did not. Mine are different, but okay. My trait 1s are exactly the same, but not my trait 2.
How different is it?
8.05 versus 9.06 to the minus 15, and it's very tiny.
Yeah.
Michelle, did you have exactly the same as he did for your?
I got the same values on both, yeah.
What the? Can I say some bad words?
Fire away.
Yeah, I don't understand why it's doing that. It shouldn't be doing that. I feel like there's. There isn't that much variation in there. Why the heck? I almost wonder if it isn't because of stupid decimals. Nope, that has no effect. No, whatever, I'm going with it. Selection pressure is exactly the same. I mean, everything's still the same, right?
Between the two, yeah.
And the you know, I just give up. This thing is just dumb.
Pretty much. Oh, don't worry. It gets worse. I just opened up the true GVs for Trinity 2. They exist.
What?
Yeah. I thought 2 and 3 would go way faster, but this is just annoying.
Okay, so
I still want to believe 3 is going to go faster.
I'm not trying to be a dork here, but to follow up for your GEBV, your predicted genetic gain 14.7 and 1.25 minus 0.8. Is that ballparkish?
My second one's going to be different since they're
I know.
But yeah, first one was pretty close. Yeah, like pretty much the same.
Sorry, I was zoning out. What are you asking?
Values for your predicted genetic gain for F or G or whatever the hell I'm working on.
And what'd you say yours were?
14.7 and 1.33 minus 0.8.
Pretty much it.
Or no, 1.25 minus 0.8 and 14.73.
Okay, then that's exact.
Okay.
So, Kyle, when you did as far as the plot cost, so for the phenotype we had 4 plots, but then are you assuming that those are in a new plot in the genome? So for some of the families we have to add both.
So for that, to calculate that, I assume that because we have 560 total lines, right?
Mhm.
You would have to grow, to get equivalent amount of data to make the same selection, you would have to grow each one of those 560 plots in 2 reps and 2 environments.
Okay, so you're assuming that for everything.
I
Okay.
posted that on the discussion board too. We'll see what he says. I mean, to me, it only makes sense that that's what you would do.
Yeah, I think that's fair.
Okay, so I'm sorry, I just walked in halfway through that. What were you talking about with that, Kyle?
I was
560
saying
total.
for calculating your gain per USD for the predicted gain based on LS means. I took $25 times 560 times 2 times 2 because that's assumed. Oh, excuse me. Yeah, unlike how we calculated it where there were 800 plots, you would actually have to grow all 560 lines.
Right.
More reps, yeah.
Yep. So isn't it? So to extract the DNA and genotype, that's $10 per line. So that's just 560. You don't have to do it in all 4 reps and or both reps and environments, or do you?
So I was thinking for that, wouldn't we just go off what we have in the phenophile? So it's only, well, I guess it's not broken out by family.
Wait, sorry, say that one more time.
I'm just saying, I followed along while you said the cost per field plot is $25. How many different field plots are you going to have? You get your total. Got that. But for the extracting DNA and genotype, It's $10 a line.
5 times 10.
Oh,
Yeah, that's it.
what the heck's
Okay.
going on?
Just wanted to make sure we didn't have to sample every field plot for the DNA genotype.
It's really weird.
That is not